sound good? Can you hear me well? Too loud, too low? Okay. We'll get started in 5 minutes. All right, everyone. Let's get started. It's 11:15. I think that's the start time that I have on the agenda here. All right. So you're in here, you are attending the FOSS at Home track, and this talk is the first one of the day, which is an interesting slot to go in, because, I don't know, you get attendees, but then also you set the tone for the day. So let's set the tone. This talk is going to be baking a Turing Pi in the home lab. This is not about food, unfortunately, so if you're here about pie, the food, I don't have any recipes for you. I do have chocolate, though, if you're into that. Not here with me, but I do have chocolate. But I'm hoping to give you some inspiration for your home lab. So let me introduce myself first and foremost. My name is Matthew Sanabria. I am currently a solution software engineer at Oxide Computer Company, and that is my website. Oh, sorry, I don't know if I clicked this little button. Sorry. There's a little switch here for, to switch the inputs on the projector. So if I do that again, just let me know. It's in a really bad spot. So anyway, let me go back to the slide. Let me introduce myself. I am Matthew Sanabria. I am solution software engineer at Oxide Computer Company. You can see my personal website on the bottom there. And I think it's probably in the process of deploying now because I just pushed a commit right before this talk. I was going to do more live demos in this talk, but the Wi-Fi has not been great. So yesterday and the day before, I was updating my slides to be more screenshots, unfortunately. But I didn't know I was going to have a hardwire here, so I could have done demos. So here we are. But I have a decade of experience across different roles: systems engineering, site reliability engineering, software engineering. I run Linux where I can, when I can, even if it pains me. Even right now, actually, this is running Linux on this laptop right here for this presentation. I enjoy learning, tinkering, whenever possible, and teaching. So before I begin, what exactly do I mean when we say home lab, right? Because everyone's example of a home lab or definition of a home lab is different. So let's agree on some terminology. What's a home lab? In my words, a home lab is one or more computers that's physically present in your home. Asterisk there, because some people have home labs in various places. But a home lab runs one or more services for your enjoyment. It could be as simple as a spare computer under your desk somewhere, or a rack of equipment in your garage or basement. Here are some famous home labs across the internet. If you've spent any time reading about home labs online or watching YouTube videos, you may have actually seen some of these home labs in the wild. You'll see here I have Jeff Geerling's home lab, the Project Mini Rack on the left. I have Techno Tim's home lab on the right, the Mini Network. I think that video just dropped like a week ago or something. And I convinced my friend to send me a picture of his home lab, because he has a much nicer home lab than I do, and he said he'll put it in the Oxide green for me. So that is my friend's rack, no pun intended, of course. So let's talk about some of the goals that I had for when I was building my home lab, right? Because if you're going to embark on some journey building something, you kind of have to set some constraints and expectations up front. That way you don't wander off into nowhere, right? You don't want to just say, oh, I'm going to spend $20,000 or I'm going to spend nothing. You have to have some constraints to keep you on track. So these were my goals and constraints, right? I wanted to understand how things work and have fun doing so, right? So I wanted to, learn, baby, learn, right? That's the song quote. I wanted to learn. I've used Kubernetes a lot in my day jobs, but I've primarily used a lot of managed Kubernetes, and they don't really give you a lot of control underneath the hood. They abstract a lot away from you, and I wanted to get away from that and see what exactly is happening here. Plus, in my role at Oxide, I am responsible for integrations with the Oxide rack, and one of those integrations, or some of those integrations, are going to be Kubernetes, cluster APIs, cloud controller managers, things of that nature. And the cloud kind of already solved those problems. I want to see how they work under the hood too. Obviously, I want to have fun. If you're not having fun, you should probably take some time to reflect and think about what you're doing and change course. I didn't want to use Helm for my Kubernetes setup, just because I didn't want to deal with the abstraction that it gives me, right? I wanted to understand what I was doing and then make the decision later on to maybe switch to Helm or something different. Also, I wanted to keep it simple and make sure it was publicly accessible, because I was going to run things like my website is currently running on my home lab right now. If you go there, that's where it's being served from. So I want it to be simple and publicly accessible. So you're probably wondering, as you should, what hardware I'm using in my home lab. Of course, right? That's why you're here. You want to know what the heck are you running. And note, before I get into it, I bought all this hardware before I worked at Oxide, and now I have access to the Oxide hardware, so maybe I'll move some stuff there. Who knows? But let's cover the hardware. Again, I had some, this is the question that was burning in my mind. What hardware should I use? I've kind of been out of the home lab game for a little while now because the cloud has ruined me. So the first question was, what hardware should I even buy? Again, I set some goals and constraints to guide me. I wanted something that had lower power usage because power is not cheap, especially in New Jersey. I wanted a small form factor, setup, ITX builds, whatever, something small. That way I can put it on a desk or put it in a rack, whatever. I wanted it to be quiet. There's nothing worse than trying to record a video or just read a book or whatever, and your fans are just blaring at you and just nobody wants that. I wanted it to have multiple nodes because I didn't want to use virtual machines for this. I wanted multiple physical nodes. I wanted a powerful CPU, and I wanted high RAM capacity. So I went with the Turing Pi 2.5 cluster board. Now, this board is a 4-node mini ITX board, and it supports various different compute modules that you can slide into those slots. It does have shared network and power, so you just put one power cable into it, one Ethernet cable into it, and you have network across all 4 nodes. And in my opinion, I describe it more as like a home lab blade chassis, so to speak, right? Think of the nodes as little blades that you insert, and that's kind of what I describe it. The deployment process for this Turing Pi is pretty simple, actually. You get the cluster board, you get some modules, you plug them in, you connect it to power in the network, you power it on, you flash some operating system, and then you're good, right? Use the operating system however you want. I want to just take a quick look at the Turing Pi hardware. So I want to look at the I/O ports on the front of the board, because there's I/O on the front and the back. And there's a bunch of stuff here that I'm not looking at, but I kind of want to highlight a few things. So each of the nodes here is connected to different components. So we have 4 slots that you can put compute modules in. Those compute modules are connected to different I/O ports on the board. So you can kind of run a variety of setups with this board. For example, node 1 has access to the GPIO pins and mini PCI, so you can put a Raspberry Pi in there or whatever and run some tinkering things. Node 2 is connected to a mini PCI slot for Bluetooth or whatever. Node 3 is connected to the 2 SATA ports on the board, so you can run storage off of that. And node 4 is connected to USB if you wanted to have USB peripherals. There's also a CR2032 battery slot for real-time clock usage, right, if you're making use of that stuff. I don't actually have a use for a battery in my setup, but when I see a battery slot, I just got to put a battery in it. So I put a battery in it. There's also a SIM card slot, which I found pretty interesting. If you wanted to deploy this kind of in a remote location or at the edge, you can have that serve as your network connection or a backup network connection. And then typical ATX 24-pin power to put it in a normal case if you want, right, with a normal power supply. The back of the board is pretty impressive as well. More I/O ports. There's 4 M2 slots. They're 2280 and 2260 lengths. Each NVMe slot or N2 slot is attached to the node on the front of the board, so you can boot directly from the NVMe and not wear out the flash on the board itself. There's also an SD card slot on it where you can put all of your images and flash the nodes directly from there. So that's what I do. I store all my images on the SD card, and then I kick off a flash command to flash the nodes. That way I don't have to be at my computer to run the flash. I can just kick it off and it runs. And here are some of the supported compute modules that you can plug in to this Turing Pi. You can do the NVIDIA Jetson, right? Various workloads there for AI, ML. I did not buy those. You can also, if you had a Raspberry Pi Compute Module 4, you could have plugged that in and used your Raspberry Pi. I also did not do that. And then Turing had their RK1 board, which is a pretty powerful chip for its size. It's a nice CPU with up to 32 gigs of flash memory and 32 gigs of RAM if you want it. So that's what I did. I ended up going with the Turing RK1 primarily because I wanted more memory, right? Because the Raspberry Pi CM4 I think only goes up to maybe 8 gigs if I remember correctly. And I think it was a 4-core CPU if I remember. But the Turing RK1 had more cores and more RAM. So I did that. And here's my build. I got a Fractal Terra case for I think Christmas or whatever, and I was going to throw a beefier ITX build in there, and then I was like, wait a minute, I have the cluster board on order. I'll just throw the cluster board in there and keep my other build in my ATX case. My goal originally was to tinker with all of this over the summer of 2024. I ordered the Turing Pi stuff in February. It did not arrive until October. So my summer was not spent doing home lab things, it was spent doing other things. But my setup is 1 Turing Pi board, 4 RK compute modules, 4 heat sinks for them, just to keep them cool just in case, 4 NVMe SSDs, and the Fractal Terror case that I got for free. Total cost came in around $2,200, whatever. Great. Pretty decent compute for the price, I guess, but also you can get better hardware for the same price, of course. We all know this. But I want to turn now to the software. So how does this Turing Pi even work, right? I got this hardware in, great. I plugged it in, great. What the heck do I do with it? How does it work? Well, when you plug the Turing Pi in and you go to its network interface, or you go to its IP address, you're going to see the UI. You could log in, create your account, whatever. And here's where you can control the Turing Pi. You can modify network configuration, you can power cycle the nodes, you can flash firmware, flash the nodes itself, all of this good stuff. And here's just the UI that you can use to power the nodes on and off. It's actually not a great UI because in order to power the nodes on and off, you have to click edit first and then click the radio button to move it over. A little weird, but whatever. And then here's the UI for flashing a node. You can just point it to an image, give it a SHA-SUM, and everyone's happy. If you need to find images for the Turing Pi, like firmware and OS, you can find some of them on firmware.turingpi.com, but there's not a lot available there, honestly. Like an old Ubuntu image, but whatever. But I'm not a GUI person, and I argue that probably you are not a GUI person either. So I know people here at SCaLE, they don't use GUIs, they probably use CLIs. And yeah, right, exactly. Luckily, the Turing Pi also has a CLI tool. It's called TPI, which I guess TPI, Turing Pi, I don't know what it stands for. People don't name CLI tools well, but whatever, it works. You can download TPI from the Turing Pi website or GitHub, and then you get access to a variety of subcommands. You can power nodes, you can get the node serial connection, you can flash them, all that stuff. All the things you can do from the web console, but more. So I did that. I was like, oh, okay, let me install TPI. Let me look at the power status for my nodes. Great, I can see the power status. I can modify the power status. I can turn on a node, I can turn off a node. And it was really fast, actually. Like, it's almost as fast as just ripping the node out of the board. You could even flash a node. So I remember I told you previously that I stored all my images on the local SD card on the Turing Pi. This is me using an image there to flash the node. So this is what I did. I just kicked off a bunch of flashes and let it go. And then I had Ubuntu installed, and everyone was happy, right? I got, Ubuntu's there. But how do I see the serial console for this stuff? Right? How do I even view what's running or whatever? Because only node 1 has access to the HDMI port on the Turing Pi. Other nodes don't have that, so you can't get the GUI, you just need to see the serial. Luckily, the TPI command provides access to get the serial console from a node. You just use the uart subcommand, and you can get the serial console right there in your terminal. However, this is great for viewing the output of a serial console. Not really great for writing to the output, right? If I need to actually log in and type a username here, or a password, or God forbid, switch my kernel, right? If I need to hit something in grub or whatever and switch something, how do I do that? Well, there's also a set command, but it doesn't really work well because you have to get first to view the output, and then see what you want to do, and then quickly type a set command up to do it before it disappears. Not fun. Instead, you can SSH to the Turing Pi board yourself and open up a serial connection using Picocom or whatever, and now you have an interactive serial console. And I use this so much for debugging, for flashing, for whatever, because there were times where I needed to reset my system, and I needed to actually hit the arrow keys to go up or down and select a different kernel or whatever. Speaking of kernel, what am I running on these things, right? Great, I showed you the hardware, I showed you how to use it, but what's actually running on this stuff? Well, I wanted to run Kubernetes, but I had no idea what operating system to run it on, right? There are various different ways to run Kubernetes in the world, but I wanted to see something that was kind of new to me, right? I've used Rancher, I've used these things before, K3s, I wanted to try something new. And again, goals and constraints to guide me. The OS needed to support the Turing Pi, minimal bloating, support Kubernetes, be secure, all these things. And I ended up with Talos Linux. And I don't really even remember how I found this, honestly. I think it was a combination of talking to people and some research, but Talos Linux is pretty cool. It's an immutable operating system designed for Kubernetes. Its sole purpose in life is to boot up and be a Kubernetes node. It's weird in the fact that it's managed via the API. There's no SSH, there's no shell, none of that. it's all like gRPC commands, over an API, than doing SSH or whatever. It is open source, and it has pretty wide platform support. It can run on the Raspberry Pi, on Turing Pi, and all these things. At the time, I was like, okay, I'm gonna use Talos. Now, where do I find an image to put this thing on, right? Like, where do I find a Talos image to run on my Turing Pi? Unfortunately, neither the Talos or Turing Pi documentation helped me find such an image. There was plenty of images for Raspberry Pis and other things, no images for Turing Pi. I ended up joining the Turing Pi Discord and researching through there, searching through messages, and I found someone was hacking at this and getting support for Talos. Luckily, I think my timing was just fine because at that time, that hack turned into official support from the Talos side. Like pull requests were created, issues were created, and Talos was like, yep, we're gonna support the Turing Pi natively on our factory.talos.dev. If you go to that website, you'll see you can download Talos for generic operating systems, for single board controllers, all of these things. So luckily, I was able to download image very easily. So okay, cool, I have Talos, now let's boot it. So I booted up Talos, and this is what I saw. Just logs. And yes, this is purposefully dirty, right? Like purposefully hard to read. This is what I saw when I booted Talos, very verbose, hard to read. I even took the timestamps off the logs for you to not burn your eyes. But I know you're still like this. You're still sitting there like, what the heck is this guy showing me, right? And I'm not gonna lie to you, at this point, I walked away from the home lab. I was like, no, we're not doing Talos. I don't wanna deal with this right now. When I came back, I cleaned up the logs a little bit, and I was like, okay, what is this really telling me, right? There's a lot of noise here that I don't need, but what is it really telling me? Well, it's telling me that I can install Talos in these various ways. So it's booted, but it needs to be bootstrapped, right? It needs to be initialized. And I can do it either interactively or with some config file. Obviously, at this point, I have no idea what a config file, like config.yaml is gonna be, so I went for the interactive installer. Ran that interactive installer command, and they presented me with a beautiful TUI, where I can enter the details for my installation and hit next, and then it installed. And great. After it all installed, I just had to download the Kubernetes config file using talosctl, export that, run my kubectl commands, and boom, we got Kubernetes. Everyone's happy. So, okay, one side note here before I go into the custom configuration. Talos is pretty cool in that it can update itself and it can update Kubernetes. So there's subcommands for updating Talos DOS and subcommands for updating Talos Kubernetes. And they were great. They rolled through the Kubernetes upgrades, cordoning and draining a node at a time and going through. Very nice. But I had a question. How do I customize my installation, right? I did the interactive install, kind of went through the defaults. What do I do to customize my installation to do more things? And remember, there was this config.yaml, I had no idea what it was. So I did a pretty novel thing, and I read the documentation. And I found out that you can generate these config files using talosctl gen-config. And all you have to give it is a name of your Kubernetes cluster and the endpoint of where the Kubernetes API is going to be served, and it will generate 3 files for you. It'll generate a Talos config file, which is just how Talos can communicate to the gRPC API. It'll generate a control plane and a worker YAML, which are self-explanatory, are the configs for running a control plane Kubernetes node and a worker Kubernetes node. Great, I had no idea what to do with these files. I was looking at these files, I was like, great, what do I do with this again? After some more reading and playing around with it, you have to keep Talos config safe for yourself because you need that to connect to initialized nodes later on. And the control plane and worker plane files are just there for making a new Kubernetes node. I wasn't running worker nodes in my Kubernetes cluster. I was running 4 control plane / worker nodes. And I know that's probably not the best way because etcd, I just increased the quorum of etcd by 1 for no reason. Whatever, I didn't care. It's a home lab. But after much more documentation reading, I found the set of commands I wanted to use to generate my configuration. I generated a new configuration saying, hey, only give me the control plane YAML and the Talos config, forget about the worker, and run a patch. So take the config that's generated and then run a patch on top to do more things. And what was my patch? My patch was just to remove a node label that I needed to remove later, tell it where to install Talos, like what disk to use, and to tell it to, hey, make sure that scheduling is enabled on the control plane nodes, otherwise you can't schedule pods at all. After I had the configuration in hand, here's what I ended up doing to configure my Talos nodes in my Turing Pi cluster. I booted them all up, ran the first command to apply the config on all of the nodes. At this point, the nodes were running, but SCD was not bootstrapped. So I ran this second command, this bootstrap command, on a single node to bootstrap etcd. And then I got my kubectl from Talos, and boom, heck yeah, we got Talos Kubernetes now. Everything's running. Great. Hardware's good, software's good, Kubernetes is up, but I'm running nothing on this right now, right? There's nothing here. So let's talk about load balancing, because one of the goals is to get traffic into my home lab. I need to be able to do that, otherwise I can't go to my website and see anything. So my question was, how does L4 connectivity work to my home lab? L4 being TCP UDP. So you can deploy a service to the cluster right now, right? And this is representative of node port services, right? The green is like one node port service, the red is another node port service. And that's cool. I can port forward those node ports if I wanted to and get access from the internet. But when I do that, I can only use that external port one time for one node port service. I can't share the same port for multiple things. And like, that's fine, we'll get to that later. But at this point, I had no idea, I had another problem. I have 4 nodes. What node do I port forward to? Right, because every node in a node port service can receive traffic and serve it. But like, if I port forwarded to like .14 and .14 goes down, everything's broken. And I have to move my port forward to another thing, that seems silly. What I really wanted was some like floating IP or load balancer that I can port forward to consistently, and it moves based on whether a node is alive or not. And I want to just really quickly rant or tangent about load balancers in Kubernetes, because they are very frustrating to deal with. Because every documentation that you read out there is like, hey man, just do this. Type load balancer all day. That's all you need to do, and it'll just work. That's what the docs say. But nobody tells you that something actually has to manage this type load balancer. There has to be a controller running somewhere that like actually makes the load balancer and does the thing. And if you're using managed Kubernetes, all of that's handled for you. You never have to think about this stuff. But when you're using Kubernetes, bare metal or in your home lab, you need to bear this responsibility doing something. And what I chose was probably what you're all familiar with, is MetalLB. So MetalLB, it supports bare metal Kubernetes. It's a layer 4 load balancer. And it uses standard networking protocols like basically ARP, spamming, and BGP. So I installed MetalLB in my cluster. And it can work in 2 ways. You have to give MetalLB like a pool of IP addresses to listen on, right? You say, hey, at MetalLB, this part of my network is reserved for you to listen on. Pick one, manage it, have fun. When you do listen on that address, you can either advertise that you're listening on it using a layer 2 advertisement, which is basically just ARP, right? Or you can do BGP advertisement, which is a routing protocol to like share routes, border gateway protocol. Now, I did this, right? I created my IP address pool in Kubernetes. I was like, hey, MetalLB, you can assign from IP address .50 to .99. And then I created my L2 advertisement, and I said, hey, when you do assign an address, spam ARP and make sure everyone knows where you are. And I could create a load balancer type service now using MetalLB, and this annotation just tells MetalLB what specific IP you want to use. If you don't use that annotation, MetalLB would just pick a random one in the range, or probably the first one in the range, I don't remember. And I did that. And nothing worked. Nothing at all worked. The service was there and created in Kubernetes, but MetalLB was not listening on any IP. Honestly, it was not listening on anything. And I was like, what the heck is going on? I had to remove this label from my Kubernetes nodes before MetalLB would work. And I actually don't even really know what this label is meant to do or what controller powers is reading this label. But if you have this label on your nodes, load balancer services will not advertise on that node. And all my nodes were control plane nodes, and they had this label. So nothing was advertising. I spent hours debugging this. I'm not even exaggerating, like 3 hours of debugging this thing. I looked at my service, and I was like, hey, I have a service. I tried to curl the endpoint for that service, nothing. Tried to curl the node port itself, not the virtual IP that MetalLB gets, but the actual node IP, and it works. I was like, okay, my service is doing its thing, but MetalLB is not doing its thing. I looked at ARP. I was like, okay, is MetalLB even like spamming ARP? Is it doing the thing? Is it replying? Yes, it was. I get a MAC address back. That means it's working. And that MAC address corresponded to the node that it was running on. I even was like, you know what? Maybe I'm doing layer 2 wrong. Maybe my network settings are wrong. I don't want to deal with this. I switched to BGP. Same thing. Errors. After troubleshooting, I realized that I was connecting to the wrong port the entire time. I was supposed to be connecting to the service port, which is on the left-hand side of the port, not the node port. Once I did that, everything was working, and I wanted to just go cry. I was like, oh, I'm the problem. And you can see there's a GitHub issue somewhere that I commented on saying, like, what's going on? It was me. So let's move off of load balancers into Ingress. Now, I had traffic coming into my machine, or into my cluster. Great. How about L7 connectivity, right? Can I share the same port and serve multiple services with that port? So as a reminder, this was my architecture up to this point. I had MetalLB, kind of giving us that floating IP model, and I was able to port forward in from that, no problem. But I really wanted a model like this. I wanted to have some layer, probably Nginx, running, listening on port 80 and 443, and then it could divvy out, oh, you came in on foo, you go here. You came in on bar, you go there. That's what I wanted. And I needed an Ingress controller to do that. I use Nginx Ingress controller, as most of us probably do for Kubernetes. It's very popular, and that's probably the only reason why I use it, because everybody else uses it. I created my Nginx Ingress. I deployed the operator to the cluster, and then I created my Nginx Ingress. I said, hey, please run as a daemon set, and please listen on .50, because that's where I'm going to port forward my port 80, port 443. I will always forward it there. I didn't need to use a daemon set, but I did. Then I was like, okay, let me create a test, make sure this works. I created a deployment in a service that was listening, right? And I created an ingress to say, hey, anything that comes in on matthewsanabria.dev, send it to the website service on port 8080. Great. I had DNS updated, everything was working. The resources in Kubernetes looked good. I was able to get the ingress resource, get the controller resource, everything was happy, and yeah, my test page was working. Great. But what about TLS? Right? I'm serving on clear text, but I'm serving on HTTP clear text, but I'm not serving on HTTPS, encrypted. So that was my question, right? HTTP is great. What about HTTPS? And then this is where I said, okay, Cert Manager looks good. Did some research. It supports TLS certificates, popular protocols like Acme via Let's Encrypt, and it does renewal all itself. So I deployed it to my cluster, and I created a cluster issuer so that any namespace on my cluster can request a certificate. I told it I want you to use the Acme protocol to get certificates via Let's Encrypt, and I want it to use the HTTP challenge in order to actually get the certificate. In hindsight, the HTTP challenge was probably a mistake, but I did. I went back to my ingress for Nginx, and I was like, hey, added this TLS section on the bottom here. Please request a cert from Cert Manager to get TLS working. That was all good. Looked at my ingress here, and I was like, wait a minute, what's going on? Nothing's working, right? I see the certificate trying to create, I see everything's looking good, but the challenge is not being fulfilled, right? Because Let's Encrypt via the HTTP challenge will send basically an HTTP request saying, hey, does this file exist on your endpoint? If it does, I verified you, here's a cert. Nothing was working for me. Again, after hours of troubleshooting, I realized that I had to add this annotation, to my Nginx ingress, because Nginx was taking all HTTP connections and redirecting them to HTTPS. So that challenge that was coming in on port 80 was immediately being redirected to 443. Nginx was like, hey, here's the invalid certificate for that, and Let's Encrypt was like, failed. It took me forever to find this annotation, because there was 2 pieces of documentation that had different annotation names. Very, very frustrating. Once I added that annotation, everything worked, and I had a certificate. I was able to see my cluster issuer, my certificate request, my certificate was there, valid, everyone was happy. And now I go to the test page, and we're served over HTTPS. Okay, everything's set up now, right? I have all of the plumbing is there. Let's put a real app on this thing. So the first thing that I wanted to migrate was my website, right? My matthewsanabria.dev blog. Pretty low risk, whatever. So I was like, let's test this thing. So my website is listening at matthewsanabria.dev. It's running on the home lab now. It's built with Hugo, which is a static site generator, and all that means is it takes a bunch of Markdown and makes HTML out of it. It was previously hosted on DigitalOcean, and I had a very bad experience with their app platform. I hated their app platform, honestly, so I wanted to get off of there. So I moved it to my home lab. How did I do this? Previously, I had a Docker file. I'm not meant for you to read this, really. This is the Docker file I used to deploy to DigitalOcean. One thing you'll note, though, is that all it does is build the site. It doesn't serve the site, because DigitalOcean is very weird, and it wanted you to like build the files, and then it would copy it out of the container and serve it itself. And I'm like, this makes no sense, DigitalOcean. Just run my container. So I moved it, and I used a multi-stage build to build my Hugo app, and then serve it via an Nginx. Nothing too crazy there. So I created a deployment to deploy my website, right? Simple deployment running this container. I exposed that deployment as a service. This time, you'll notice that the service is not of type load balancer. It's just a cluster IP, because Nginx is my ingress, and it's going to be able to handle that. And I ran it. And that didn't work, right? So I was like, okay, what's going on here? I got this beautiful error. And does anyone know, does anyone have an idea of what's happening here? Yes, kind of. Any other guesses besides ELF? Mismatch of architecture, exactly. I was building these container images on my framework laptop, which is AMD 64, and I was pushing it up to GitHub to serve it, and it was running on my Turing Pi, which is ARM 64. So we're not in AMD 64 land anymore. So at that point, I was like, for real? I was like, really? I used Podman's BuildX feature to do an emulated build for ARM, whatever. And I was like, I don't want to do this anymore. Made a GitHub action. This is like a typical setup for GitHub actions. Log in, set up the emulator, run your build and push. So I did that, and now I have AMD and ARM builds pushing to my GitHub registry. Great. At this point, though, I don't have a deployment process for my website. I just kind of run the container myself, or run the deployment myself. If I created a new image and it got pushed up to GitHub, there's nothing that would redeploy it for me. This was my redeployment process, me just running rollout restart. Of course, that doesn't scale, but we'll get into that later. And here's now a reminder of how traffic was flowing in. Same diagram from before. I'm listening externally on port 80 and 443, forwarding that to Nginx's ingress controller, and then from there, the ingresses are going to various services. Great. Another problem. What about dynamic DNS? What happens when my public IP of my house changes? Because they can do that, right? My ISP can change my IP, or if my modem's down for an extended period of time, I'll just get a new IP via DHCP or whatever. What do I do? So I am running unified networking equipment or ubiquity networking equipment at home. It supports a dynamic DNS feature where anytime the WAN IP changes, it'll send a request to say, hey, do something. And I needed to speak this dynamic DNS protocol. What exactly is that protocol? Well, it's just a GET request to /nic update, and it gives you the IP and the host name to use using query parameters, and then the response is always going to be HTTP 200 OK with error messages inside. So very annoying that it uses HTTP 200 to mean OK and error, but whatever. My next question was okay, if I implement this protocol, can I run this as an internal service? And I kind of went a little wild here in my mind. I was like, how do I run an internal service? Do I do another ingress? Do I do this? And I was like, no, silly. I can just make another Kubernetes service and run it on a different IP. It's fine. So that's what I did. I wrote a program, spun it up as a container, put a service in front of it, and the unified controller wants TLS on that, and I didn't have a way to do internal TLS certificates easily. I mean, I could have done self-signed via Cert Manager, but instead, I did self-signed and I stored it right in the program itself. So if you go to the GitHub that's hosting the service, you will see a TLS certain key. And I don't care because it's self-signed and it doesn't need to be validated for anything. So you're probably asking okay, Matt, what does this program that you wrote look like? Well, it's available on my GitHub, sudo Mateo, unified dynamic DNS. You can see it. It's not the best code at all. I wrote it on the airplane here. And all it does is it receives a dynamic DNS request. It will take that request, say, hey, I have a new home IP. I will update a variable that I have in Terraform Cloud for one of my workspaces, trigger a run, and then all my DNS records get updated to the new IP. Very nice. And that's basically the basic flow. It's not foolproof, right? Because there's a chance where the update can come in and my program is either not running or whatever, but it's good enough. And I want to move into now CI/CD, because up until this point, I was deploying everything manually. kubectl apply this, kubectl delete that. Everything was being done at my keyboard. So I wanted to know, hey, how do I deploy this stuff automatically? So I wanted to set up something to do that, but I didn't want it to be like Helm, right? So enter flux CD. Sorry, this is like slipping off my bald head. So I ended up choosing flux CD for no other reason than it was either Flux or Argo, and I've never used both of them, and I rolled the dice, right? Here you go. I bootstrapped Flux into my cluster, which installs all of the necessary stuff into the Kubernetes cluster. And Flux is basically, the way it works is you have controllers running in your cluster. It's looking at a GitHub repository, in the GitHub case, waiting for manifests to be pushed to that location, and then it'll pull those manifests and apply them to your cluster. That's basically the flow of Flux. So I configured a Git repository. I said, hey, look at this location, this home lab location. All public, by the way. You can go browse. It's fine with me. Every 1 minute, check. See if there's any new manifests. If there is, pull them, apply them. Flux also uses customization, to my knowledge, or at least to my reading. Now, I didn't do anything special with customization at all, but I think Flux needs it to operate, and I didn't do anything more than just let it do its thing. I'm not doing any customization thing. Maybe I will in the future. But if I wanted to trigger a Flux like reconcile, I can do that via the CLI. I can say, hey, Flux, reconcile yourself and check for updates. And that's great. But I did have a problem, though. What about updates to my container images? Because at this point, I was using like the latest tag, and I was just restarting my deployments. That's not a good practice, obviously. So I wanted to have the images update automatically using a better tag that's not latest. Here's a reminder of what I was doing up until this point. I was just doing a rollout restart. Now, it turns out Flux actually supports image updates. I didn't know this at first until I read more of the documentation. But you can tell Flux to watch a registry, like a container registry, for changes, right, for new tags. So I did that. I created this image repository resource using Flux. I said, hey, watch my website repo for new tags every 5 minutes. And then I wrote an image policy, because in order for you to, this is great, that allows Flux to get new tags, but there's no ordering to these tags. How do I know if this tag is newer than this tag, right? It's all git shaws at the end of the day. What is new? So I used a pattern. Like I made tags of a certain pattern with the branch name, the short commit, and then timestamp. And then I told Flux to pull out the timestamp, because that would be a monotonically increasing integer, right, epoch time, and use that as the ordering. That's new. I then updated my CI/CD process to build containers with that tag, right? Get the SHA, get the time, put it on the tag, have fun. And then after that, I know this is probably hard to read, but I had to tell Flux, once you've pulled new tags and you've ordered them in a certain way, what do you do, right? I told Flux to go to my repo. When you find the new tag, go to my repo, go to this website.yaml file, and push the new tag as a commit to that repo. Because then, that'll push the new manifest to that location. Flux would then read that new manifest and apply the stuff. So I had all of this nice automated deployment going. But you might be wondering, how the heck does Flux know what line to update? You have to give it this little tag here, and that's basically just like a field tag that tells Flux this is the line you should update with this image policy. So anytime Flux sees a new tag, it'll find this line and update it. And now I had automated updates. This was not me, this was the Flux bot doing this, and I had automated updates working. Everyone was happy. And I did push a new commit before I started this talk, and hopefully it's live on my website. It just says hello SCaLE essentially on my website. So yeah, that was GitOps, right? I don't even like the term GitOps, but I was doing GitOps. Great. Let's move on. There's more stuff. There's always more to do. I had up to this point no persistent storage, right? My website was built as like basically a static binary essentially, and deployed. But I had no like persistent storage, no databases, no nothing. So what can I do about persistent volumes? Well, enter Longhorn. Now, I'm not really too familiar with the different CSIs that are out there, container storage interfaces, but research led me to Longhorn, It seemed to be a pretty good distributed block store that can work on your bare metal clusters, and it was part of the CNCF. This is a general architecture of Longhorn. Basically, those SSDs that are on my Turing Pi, Longhorn would look at those. It'll like make replicas, expose that replica to you in your pod as a volume, and just manage all the storage for you. Very nice. I applied Longhorn, great. Everything was great. I then tried to create a volume, but Longhorn wasn't even running yet. Even though I did the apply and those services were created in Kubernetes, I was getting like crash loop backoffs or whatever. And I was like, what the heck's going on here? I had to update my Talos nodes to mount varlib Longhorn into the kubelet. I didn't really know why I needed this, and even people in the Turing Pi Discord didn't really know, but I did need this to work before Longhorn would start up. It looks like I did some extra research of my own. It looks like the way Talos works is it mounts /var as like an ephemeral volume, and ephemeral is a really bad term here because it's a persistent volume. It survives reboots and stuff, and it's actually where Talos stores the etcd data for the cluster. So I mounted Longhorn into there, everything was working, Longhorn was up. And now I was like able to create a persistent volume claim, and I had volumes. Everyone was happy. I mean, everyone being me, I was happy. Great, I have volumes. Let's deploy something that uses the volume. So I wanted to deploy a test application to my cluster that makes use of this new persistent storage that I had. And what did I choose? Pi-hole, right? It's such a simple app to deploy, super low risk, but it also needs persistent storage because it stores its records and such and configuration in a database. Plus, I haven't really made use of Pi-hole much before, so I wanted to give it another go, right? I deployed Pi-hole, I created a new namespace for Pi-hole, I got my persistent volume claim, I said, here, Pi-hole, that's where you're gonna store your volume. I created my deployment. The deployment is just running the Pi-hole image and mounting the volume into like a directory on the container. And I had to add this DNS config before Pi-hole would like work with DNS. I didn't know why, so I left myself a to-do to figure that out later. Then I exposed Pi-hole as a service. I was like, okay, Pi-hole needs to listen on port 53, TCP and UDP, because that's what DNS does. So I told Pi-hole to run as a load balancer service on 99 and expose 53 TCP and UDP. Now, like, when I was doing some reading here, I read that a lot of people use two services for this. They separate a TCP service and a UDP service. I didn't see any good reason for doing that, so I left it all as one. So if you know a reason, let me know after the talk. Everything was deployed. I tested it. DNS was working. Great. You can see the initial request was, a cache miss, so I had to like actually go out and do an authoritative lookup, and the rest of them were served from cache, so they were much quicker. And then I had one more app that I wanted to deploy to this home lab cluster, before I kind of ran out of time. What about something else? What about a stateless app? Let's deploy a Discord /command to the home lab. I have built very trivial /commands before, and I wanted to like use this as an excuse to over-engineer a bit and tinker. So I deployed an app that I wrote called YeetCode. It's just a /LeetCode /command that retrieves a random LeetCode question from LeetCode. I have a Discord server where I help people like in their career development, and we do a bunch of LeetCode together. And we would always like select the first question and do it, and then we're like, what's the next? I don't know, what's next? And then we're like, you know what? We'll just make this a computer's problem. Let's pick a random question. And that's what this program was. So I ran it on my home lab. I created a new ingress, so it lives at yeetcode.matthewsanabria.dev. It's a new ingress, new TLS cert, whole 9 yards. And this is how it works. You just run /LeetCode, and it prompts you for the difficulty, and you give it easy, medium, hard, because that's the only 3 difficulties for LeetCode, and it'll send you a URL for the LeetCode question. Now, if you've never built Discord /commands before, it's really like 2 parts. One part is you have to tell Discord the definition for your /command. You have to say what the command is, the options that it supports, all of that stuff. And then you have to, sorry, I was just looking at the slide again, making sure it wasn't cut off. And then you have to deploy your service that handles the /command. So what happens is when someone types the /command in Discord and hits enter, Discord will read that, send your app an interaction, it's called. Your app has to verify the interaction and respond to it. That's the whole setup. So I did all that, it worked, and here's it running, me spamming the command a few times. But let's have some fun, right? What about telemetry? Like, how do I see this application and what it's doing? I used OpenTelemetry in this app to send application tracing to Axiom, and I figured I'd wear the shirt because I need to save my Oxide shirts for next week. So I instrumented my app with tracing, right? I got rid of all the logging, all the metrics, and I just did tracing, and I sent it all to Axiom. This code here is just Go code that says if the Axiom API key is provided, send traces to Axiom. If the Axiom API key is not provided, send it to standard out, right? It's pretty simple. I didn't end up using the OpenTelemetry collector here just because time. I didn't really have time to set it all up properly, and I've used it very extensively in my career, so there was no new learning there for me. So I was like, let me just skip that and just send it from the app directly. Axiom has a little weird quirk that traces have to have a parent span ID in order for them to be visible in the UI. If they don't, they're just not visible. And I had everything as one big span instead of doing child spans. So I was like, okay, let me just move a function out and make a child span. And that's what I did. And then once I did that, I got this beautiful dashboard in Axiom that showed me the number of spans I'm getting, how many spans per minute, the duration of those spans, just general. This is a CAN dashboard that Axiom provides once it sees that you're sending data. Cool. But I wanted more information, right? If I clicked on a trace, I can see that, okay, when I receive the interaction, I take 652 milliseconds to respond to it. Of that, 489 milliseconds is spent fetching a question from LeetCode. I can definitely optimize that by prefetching a couple questions and storing them in cache, but it's a home lab. Who cares? Right? If this was a system design interview, that would be my answer. Here's my offer, have fun. I then wanted to create a more custom dashboard, and I want to say hey, I wanted to answer two questions. What's the breakdown of the easy, mediums, and hards that are being requested? And what are the latest questions that were being requested? So I created this dashboard in Axiom. Very simple. And here's the code for those dashboards. Axiom has a piped language. It's called APL, Axiom Processing Language, I think. And it's basically it's kind of like a Splunk-like language if you think about it. And you can just query your data like that. So these are the queries that power that dashboard. Cool. And let's start to wrap up a little bit with some of my lessons that I learned from doing all of this stuff. I know I've been kind of talking at you for 40-something minutes now, but let me tell you some of the lessons I learned. Lesson number 1. The cloud has ruined me. Not gonna lie. All the documentation for Kubernetes and home lab things or whatever always assumes that you're running in the cloud. The cloud abstracts all these things away from you and doesn't tell you the magic that's happening under the hood. And honestly, when I looked at it from a more objective standpoint, using the cloud throughout my career, I'm not saying the cloud sucks. That's not what I'm saying. But using it so much and relying on it so much really atrophied my skills as an engineer to learn things on my own. Right? I just kind of relied on the cloud to solve it for me in the name of solving business problems, but then I was less marketable because I didn't know what was happening. So this home lab work and the work that I'm doing at Oxide helps me remember why I love this field in the first place. I love knowing how computers work, actually work, not just making, hitting a button and it works. I want to know how things work. Another lesson was I needed to leave some time for debugging. As I told you, I spent hours debugging very simple problems, and it's just because I didn't know what I didn't know. So if you're doing new things in your career, leave some time for failure so that you can recover from it. Also, another lesson I learned was annotations are wonderful and scary. A simple annotation can do wonderful things for your Kubernetes cluster, but also break everything. So just be careful and read the documentation for the annotations. But also know, documentation for whatever you're doing might not exist, and you are the best source of documentation through your trial and error. Also, remember to ask questions. It doesn't show that you're not smart, it just shows that you're curious. And what am I going to do with this home lab in the future? I'll run through this really quickly. I'm going to break things up into multiple namespaces. Everything's kind of deployed in the default namespace right now, and I want to break that up a little bit. But deploying an Nginx Ingress controller across multiple namespaces is a little complex, and I don't really have time for that. I also want to use secrets integrations, so that way my secrets aren't just manually created by me, they're stored somewhere else. Maybe the 1Password operator, I don't know. I want to deploy and document more. I have more services I need to run on the home lab, but I just didn't get time to do it. And I want to write some more controllers, right? Actually, I want to write more operators, but I really don't like the term operator for Kubernetes. It's a really, really bad term in my opinion, but I do want to write more operators for my home lab. And then 2 more things. I want better observability. I'm getting no metrics from the Kubernetes nodes right now, not because I don't want to, I just didn't have time, right? I'm not using kube state metrics yet. I'm not getting node health, CPU, memory usage, none of that. I also don't care so much because there's not much running on it yet, but whatever. And then lastly, I want to have some concept of disaster recovery. I'm not backing up any of my volumes. I have no written plan if anything goes wrong. If you were to go to my home lab and steal my Turing Pi, okay, I have nothing like ready to recover from it. I will get there. And with that, I just want to say, go out there in home lab. I hope this talk has inspired you to just tinker and learn. And yeah, thank you for having me here. Okay, I had no idea that this was going to be an hour talk, but I'm glad that I got to fill it. And I'll be here to answer any questions for y'all.
Did you create do you have a HA setup for your API service?
Sorry?
For the API gateway, do you have a HA setup for that?
No, no. It's just the Nginx like Ingress controller running as a daemon set. So technically MetalLB should fail it over to a different node, and then that node can handle it. But it's like, is that really HA? It's all running on the same board, so.
Yeah, because Talos is a big setup if you want.
Oh, you mean for the Kubernetes API? Sorry, I misunderstood you. Yeah, yes, I am. I'm using the virtual IP feature for that. But like,
One issue I ran into with that was it depends on SCD.
yeah.
So if SCD platform,
Yep.
you use virtual, I just ended up.
And I ran into that when I was doing the rolling upgrade of Kubernetes. The node that had the virtual IP for the Kubernetes API, when it goes down, you're just like, okay, I'll just wait 10 minutes. See you later. Yeah. But it works okay though for what it is. At least they tell you that in the documentation. You know, so that was good. Any other questions, comments?
Yeah, you're lucky you didn't have the switches we had 20 years ago.
Oh, I believe it.
The hardware switches, you had to put some bucket. You got everything, software, identifies conflicts,
Yeah.
ports.
Oh, I get it. I remember deploying some old equipment, and I love what I have today. There's a lot of good hardware out today.
How did you get the first image on your Turing platform?
Before they had it on factory, I just scoured the Discord. I asked questions. I was like, hey, I see you all are building images. What are you doing? And then people really didn't give me much of an answer except for here's my GitHub repo. And I just kind of like read it, hacked at it, and pulled. Some people had built images already without Talos extensions, and you need some extensions to run things like Longhorn. So I used those at first, and by the time I got to the need for Longhorn, the image is already up on Talos. So I switched to that. But the initial image, I either built it myself or downloaded it from some random person's GitHub.
Follow on, in the standard standalone Pi world, you image the SD card, stick it in and go, but you've got 4 on that board. How do you get into
Oh, yeah. Okay. So each node has flash memory on it that you can run the OS off of if you want. But some people say don't run the OS there because it just hits the lifespan of the flash. I'm running the OS on the NVMe that's attached to each node, and I just flashed each node one at a time. So what I did was I flashed each node. The OS was running on the flash of the node. Then I went into the node, copied the OS to the NVMe, and then rebooted, and it booted from the NVMe.
and then all subsequent updates go to the end?
Correct, yeah. This is also documented on Talos' website now. If you go to like Talos and search for Turing Pi, you'll see a way to run Turing Pi off the NVMe instead of the flash. So I just followed that process. Yeah.
If you're running a system, because this looks like it's mostly CPU and RAM.
Yeah.
What about solid state drives and things of that nature in that system?
Yeah. So the question was like, what about other hardware? Like, the Turing Pi is mostly CPU and RAM. What about SSD? On the back of the board, there's NVMe drives that you could attach, and they link to the node.
Some kind of limitations is the size.
No, I didn't see any limitations on size. I put 2 terabyte drives in there. I'm never going to reach 2 terabytes of usage on that thing. But I guess you could probably go up to like 8 or 16 or whatever M2 drives are nowadays. I don't know what the max is. But anything else? Questions?
So RK1 requires a specific build?
Correct.
Okay.
Yeah.
So I don't have my, long story. It's in the queue to get my board, but I've got like 4 RK1s.
Yeah.
And I was just like, oh, I just throw a Raspberry in there.
That was my thought at first too. I was like, oh, this is it's like a Raspberry Pi, right? No, it needs a specialized driver or a specialized OS for it, like an OS image. And
How many are
From what I've seen, Ubuntu is one of the more supported ones, although I looked at the Turing Pi Discord and the person that was maintaining the Ubuntu stuff was like, nah, I'm done, man. So I don't know what the future of that is. Now that Talos has it as their official image, I think that's going to stay supported. Everything else is like, you probably have to go hunt around the internet, which is one of the drawbacks for getting the RK1. It's a powerful board. Like, that thing slams. But good luck trying to find an image. You're pretty much on your own for that, which kind of sucks. But it's getting more popular, though, because more devices, not just the Turing Pi, are using that chip and starting to become more popular, which is good for us home labbers.
Can you mix the boards?
Yes. Oh, yeah. You can mix and match modules on the Turing Pi if you want, because like different modules are connected to different peripherals, and you can mix and match them. I could have done that, but I didn't.
So you said like slot 3 is 7, right?
Yeah.
So you're saying that's the only board that has access to 7?
Correct.
And then like, what was it, 4 has USB?
Correct. 4 has the USB headers. Node 1 has HDMI. Node 2 has pretty much nothing except for mini PCI. But yeah, so you can like put your GPU module in one slot. You can put like a generic module in slot 3 and provide storage. You can just mix and match. Which, I mean, I get it. There's only so much bandwidth because the slots are just DDR4 slots. That's all they are, right? Because I don't know if everyone knows, but DDR4 is not just a memory. It's not a memory type. It's actually a slot specification. You can put memory in that slot, but you can also put other things. So this is just a DDR4 slot, and there's only so much bandwidth that slot can handle. So I guess they mixed up the peripherals to account for that. But yeah. But they do all share the network. They do all share the power.
So for a storage strategy, like what we do with Longhorn, that's the way to get some resiliency in the storage side. Because otherwise,
Yeah, that's the Longhorn is probably the most expensive way to get the most storage. But you could, the documentation on Turing Pi for Kubernetes, an alternative way is to have Node 3 be an NFS server and have the SATA ports that are attached to it, you know, plug a 2.5-inch drive in there and serve that and use that for your Kubernetes storage. Then you have a single point of failure, which is why I didn't do it, yeah. I wanted to be able to pull out a node and not care, if I wanted to. Granted, yeah, I'm still sharing power, still sharing network. I don't care about that. I'm not a data center at home. I just wanted to be able to like mess around. Right. Exactly.
Most data centers have 2 power sources, one
Right.
top, the other one.
Yeah, I was just in a data center like last week doing an Oxide installation, and it's amazing how cool they have gotten over the years. But any last minute questions? I can put them up. I'll probably just put them up on probably my, you know, that GitHub profile link, or I'll probably just put them up on my website or something, somewhere there. I'm not gonna lie, I finished them last night, so I didn't get a chance to put them anywhere. Cool. Well, thank you everyone. Really appreciate you coming here.
Hello? Good? I am a loud talker, and I'm talking low now. I'm normally a very loud talker. Okay, thank you, thank you. Okay, I'll turn this off for I like to talk to people before I start talking so I'm less nervous if I know you guys. How's SCaLE been for everyone? Yeah? Whose first SCaLE is it? Oh no, it's just me and you. Yeah, wow. Oh, 2, very nice. I didn't realize it was gonna be eight conferences, I said, and so I don't even know, is this a conference or is it just a track? Faucet home? Track? Yeah. How many people are like history buffs? Okay, I will not call on the people with their hands somewhat up, but you in the back, excellent, thank you. Also, is somebody gonna come in like an MC? Somebody said that. Sometimes I do, but okay, help me think of something fun to introduce myself with.
They're supposed to be, but I've done it for other rooms, so I can do it if you
Oh,
want.
oh no, this is the one. Don't stand there. Okay, no, that was me. Yeah, yeah. Sure, yeah. You guys help me think of something interesting to introduce me with? I love that. In fact, okay, this is my dog, Lucy. Okay, well then you won't be able to say it. I'm from San Francisco. Anybody else here from San Francisco? Is everyone local?
Pretty much.
Who's the farthest? Huh? Lancaster, hour and a half. Anybody farther than that? Boston. Okay, so you're immediately. Anybody farther than Boston? From Europe? They came just for this? Wow.
Yeah, they had a bunch of guys, they had like a little demo thing, and it wasn't working, and it was working up at the expo hall, and they forgot to set the voltage, the 50 cycles, European voltage versus 60.
Oh, yeah, yeah. I couldn't figure that out. The biggest secret I know for live demos for physical things is to set my my hotspot as the same thing, so then I don't have to change it when I come here, and then just work off my phone. Yeah. I don't know. I saw some.
There is a hardwired Ethernet there too.
I did see that.
Far more reliable, but tethering is.
I realize my audience now could probably give me some pointers on the best way to do live demos in the future. Yeah. Oh, I don't want to scare anyone out of this room, but one sensor I did bring with me is an air sensor. And yeah, so anybody else carrying an air sensor with them? I just happened to look at it. We're still good. No one's gonna die here. But it is a little bit high, and I think it's because these rooms are a little bit stuffy. Yeah, just a scotch. Like I was walking through the expo hall, which has super high ceilings, and like huge HVAC systems. I would expect it to be. Oh, of how dirty our air is?
No, I understand, yeah. 877 is not terrible.
No, it's not terrible. Yeah, yeah. You guys, it's still in the green. Don't worry. I know. When somebody says that, then I'm like, ugh, dirty air. Okay.
It changes color to 1500, I think. I have one of those.
It's good. Battery operated.
Building was being used for fire
Evacuation.
yeah. So yeah, who knows?
Where's the air vents here?
The big wide,
Oh, the huge white thing?
no, the wide block.
Oh, yeah, yeah. Got it, okay. That looks like the, okay, let me see.
There's two returns here.
I'll keep track of my own time too. Because I saw signs in the back, but, no, well, yeah, okay, yeah.
It's supposed to start in, you still have 2 minutes.
Okay, let me reset, because I'm going to forget to reset. I also don't know how long this talk is actually going to be, so we'll see, we'll look at your faces if I need to go faster or slower. What's your name?
Oh, I'm Steve Wong.
Steve? Joyce?
Pleased
Nice
to
to
meet
meet you, yeah.
I'll just introduce you as head of developer relations.
Oh, sure.
for VM, and maybe you can tell us a little.
Oh, sure, absolutely, yeah. From where?
Yeah, I go there regularly.
What's that?
It's a hackerspace
Oh,
in
yeah.
Fullerton, and
Ooh,
somewhat close here, about 25 miles away. They specialize in machine tools and things primarily, but they do electronics as well.
I'm looking for a hackerspace up in San Francisco. A lot of the big ones have closed recently, so just got to buy all the equipment myself. Yeah. Who has a CNC? Oh, make friends with these people. Metal, wood? Okay, all right. That's a flex in this room.
If you ever come down to visit 23B,
Yeah,
has, like big
Fullerton.
CNCs, like they
Okay.
call it milling machine from a
Yeah.
bullshit.
Oh,
So there've been people
like
who
large
managed to
pieces, yeah.
make motorcycle engines and things.
Still cool, yeah. So I can't make my jingly jangly earrings there.
Oh, you could.
Teeny tiny little, yeah. I forgot to bring Kleenex too. I shouldn't have mentioned the dirty air and then that in the same sentence. It is. Good
Okay, I
eye.
think it's time to start. So this is the at-home track at the SCaLE conference in 2025. Please join me in welcoming Joyce Lin, who's head of developer relations at the robotics company VM, and we'll let her tell us what VM is and then go into her talk.
Thank you, Steve. Thank you, everyone, for chit-chatting with me, so I'm more comfortable standing up here. As I mentioned, I'm from San Francisco. I'm the head of developer relations at VM. This is my dog, Lucy, who unfortunately is out of focus because it was portrait mode, but I'm very excited to get back to her later tonight. So VM is an open source engineering platform that is designed to help you connect software to hardware, which means I get to work with robotics, IoT, and I basically get paid to play around and build things. Something I have noticed, and maybe it's not in this room, but in general when I talk to developers, that a lot of us are very high-tech people who are very low-tech at home. We're smart people, we do smart things at work, but when it comes to our lives outside of work, we don't have the time or the energy to invest in tech for our smart homes. So the name of the session is, Are we really making the most of our smart home technology? So we're going to start with a history of smart homes, how to choose the right sensors, choosing the right actuators, the right software and AI, and some examples that I've come across in making smarter automations. Also, oh, fun, I didn't bring any stickers, so sorry, but I am going to be giving away a rover, and this is the first time I'm trying this. I know logistically it's not great because it takes me like 5 minutes to get my phone out and take a QR code, but if you sign up using this QR code by the end of today, look around you, your odds are pretty damn good, and look who has a camera up. I will show this one more time at the very end, so don't let me forget, but I'll ship you a little rover, a little four-wheeled base that you can play around with. Okay, so let's start with what is a smart home. Actually, let's start even simpler. What is a smart device? What makes a device smart? Marketing. The user, connectivity. Okay, so very simple answer, but that's what I was looking for. The first internet-connected device, does anyone know what that was? Very good guess. Wait, yes, toaster. Very good. So this was a toaster in 1990. It had one control, on and off. You could make your toast darker by leaving it on for longer. The next year, I think they had a robotic crane to insert the bread into the toaster, but that didn't take off commercially for some reason. A few years later, the world had Wi-Fi. okay? You had blazing fast speeds of 2 megabits, but it was still another year or two before routers became affordable to the masses. But as wireless technology was starting to gain popularity, Z-Wave was introduced, specifically for low-power smart home devices, but it didn't become an open standard until many, many years later, not until 2016. This same year, 1999, MQTT was introduced. It was originally designed for monitoring oil and gas pipelines, which had really unreliable connections when you were out in the field. With MQTT, clients can publish data to a central broker, which can then publish that data to other clients that are subscribed to a specific topic, following a pub/sub or publish/subscribe communication pattern. But back to Z-Wave. I know a history buff is back there. Even though Z-Wave could do mesh networking, another technology really took off with mesh networking, which started as an open standard since day one. Zigbee, yes. Like Z-Wave, it was also designed for low power smart home devices and really popularized mesh networking. So Philips Hue lights were some of the first mesh networks in your home because it could relay signals directly to each other, almost like mini routers, and that extended the range and reliability of your home network. A few years later, the iPhone, it wasn't the first internet-capable smartphone, but importantly, it had an app store. So this laid the groundwork for mobile control of other devices. And then a year later, some guy came home from his winter vacation and was really pissed that his house was so cold and said, why can't I control this? He invented the ecobee smart thermostat, the first Wi-Fi enabled thermostat. He was Canadian, so he was measuring in Celsius. We're all local here, right? Fahrenheit all the way. So users can control the temperature using a web UI. And the idea of remote control had been around since the 1950s, but that was going to be like your TV remote, which is an IR or RF control. This was cloud-based control, right? You could change the temperature from anywhere in the world as long as you had internet access. And then we had the first open source smart home platform. This is a trick. Huh? Mr. House? Oh. Yes. Java-based? This was kind of a trick question. I thought everyone's going to yell something out. OpenHAB. So 2010 supported multiple protocols, gave you local control privacy, and then another smart thermostat. People love their smart thermostats. There's actually 2 milestones here. So Nest was a self-learning thermostat, meaning it would adjust automatically based on your habits so that it would anticipate when you would leave for work or come home from work and adjust automatically. It also, important milestone here, it also tracked energy usage and suggested ways to save on your bills. A year later, we had Siri, which had been around for a while, but it was acquired by Apple and then released to the public as the first mainstream voice assistant for your iPhone. So it's not yet for your smart homes, but it introduced the idea to the consumers of voice control. And then a very popular open source smart home platform. Yeah, there you go. So it also gave you local control and privacy without relying on cloud services, but what really gave Home Assistant wings and caused it to become the major player it is today was the engaged community. People were building their own integrations and customizations and sharing them. Interestingly, I tried to find an early photo of the dashboard, and the dashboard hasn't changed since 2013, until I think earlier this year when they had a new release. So we were already talking about Siri. The world already knew about mobile voice assistants, but the first one to be used at home, the first voice assistant to be used at home, Alexa, yes. Smart speaker with a voice assistant capable of, oh, scary, controlling other devices. So this means we're moving from isolated devices to interconnected voice-activated environments. 2 years later, we had ESP32 microcontrollers that had Wi-Fi and Bluetooth capable. And it was really what made it important was it was a game-changing price point, which allowed not just the industry, but DIY hobbyists to do more with local control. And then a few years ago, Matter is proposed as a universal standard for smart homes. It's backed by some big dogs, but there's still a lot of work to be done here, but the goal is to make devices truly interoperable across ecosystems, across Apple, Google, Amazon. Okay, so back to our earlier question, what is a smart home? This idea has changed a bit over the years. Starting in the 1990s, we had standalone devices that could be connected to the internet, our little toaster. In the 2000s, we started designing devices intended to be connected to the internet. You had remote control, remote access, you had basic voice control, but it was cloud dependent and not yet used for automation. 2010s, we have the rise of smart home ecosystems, but this technology is used in a very personal part of your life, your home. So then people started thinking about privacy, customization. So alongside the rise of the proprietary systems, you also have your open source DIY systems at the same time. And now, AI is kind of having its moment, so machine learning is becoming mainstream everywhere. We can now predict behavior instead of programming explicit commands. And what's next? We'll come back to this, but today, you can say we're talking about, I can't read that on my thing. Can you see that in the back? So we're talking about enhancing convenience, security, and efficiency to learn from user behavior to anticipate needs rather than just responding to commands. Whose home here anticipates your needs? Okay, a couple people. I don't think it's that widespread yet. So let's start with some examples you might actually have in your home, besides the 5 hands I saw wiggly woggling. Let's start with detecting when you're actually at home. So imagine this, you're reading quietly in your room, or maybe you're sitting on a toilet somewhere. You're not moving a lot, right? The lights go off. What do? Woo, car wash van, okay? So you start waving your hands around, and you're trying to trigger a PIR sensor, which measures the change in infrared radiation or the temperature change. So I'm a warm human, and I'm walking past a cold wall in a zone. Change in temperature, motion detected. That means if I'm sitting very still, there's no motion. That means if the vent kicks out some heat, motion, right? So PIR detects motion, not really presence. Is somebody actually in the room? It's guessing if you're in the room. So something that can be more useful for something like smart lights might be presence detection. So now you have millimeter wave sensors which measure the speed and direction of moving objects to generate that picture in the top left or top middle there is a 3D point cloud. Teeny tiny little waves, super high precision, which means it can differentiate between a moving target and a static target. Even teeny tiny little motions like I'm breathing or my heart is beating. So even more options for sensors, you have ultrasonic, even cameras. All of these types of sensors can inform how you automate smart lights, security alerts, even controlling the temperature in a room. So what's important when you're choosing a sensor? Well, obviously, weigh the pros and cons of different protocols for your range, power efficiency, and reliability. Do these sensors work with your existing platform? So are you on Home Assistant? Do you already have an MQTT broker set up? Trade-off between cost and accuracy. So that PIR sensor I'm talking about isn't perfectly useless. It's useless when I'm in a room, when it's a human, and I want to have convenience. But say it's my backyard, and I just want to scare away that raccoon, right? It's not that big of a deal for false negatives or false positives, right? So I could use a cheaper sensor for something that's not that important to me. And if you want to level up your sensor game, leverage your sensor networks. And this isn't just about having a bunch of the same kind of sensors all throughout your house, but rather gathering input from different types of sensors. Okay, that's sensors. Now let's talk about actuators. So another scenario here, gosh, you guys are all local. So last night, you didn't stay out late, you didn't do any of the networking, you just went home, you got 8 hours of sleep, and then in the morning you wake up and you're like, ugh, I feel kind of groggy, right? What is it? It's your CO2 levels, right? The CO2 levels in your bedroom are high. So the saying is that indoor air quality can be up to 5 times more, less healthy than outdoor air. So we typically think of pollution with outdoor air, but indoor air quality, we're indoors all the dang time, right? So you have CO2, which we know is very high in this room right now, I'm so sorry. We also have PM2.5, which is what teeny tiny little particles for wildfires, right? VOCs, if you're cooking or burning candles, VOCs are high. So I built this air quality monitor here because we have wildfires in San Francisco, and I want to know when do I close and seal my windows. And actually, I took this yesterday. Something happened in my house yesterday, and I don't know what it was, but there was a spike in PM2. So then I looked up, was there a wildfire? So you can use it like that. So what do you do when you do see a spike like that? What could you do when you measure bad air quality? Well, instead of just reacting to a notification, like if I got a notification that my air quality was bad in my home office, I'm not there. I can't do anything, right? So that's fairly useless. So you can automatically activate an air purifier, run an exhaust fan, open a window if you have a smart window, or you could do what I did, which was, if anybody here, don't come at me. I know I need to put duct tape on this. You can make your own air purifier, right? This is actually a very common thing. It looks a little jank, but it's a very common thing for you to build. And I just had a box fan around, but you know what else everyone has around? A smart plug, right? So I made a dumb appliance smart. So what's important when you're choosing your actuators? Identify your end action. Do you need relay switches for an on-off binary action? Do you need variable action, like I need to turn this on 80%? Do you need motors for any kind of motion? What are your power requirements? Are they battery operated like this guy? Is there a specific voltage? You need to have it hardwired. Is it power over Ethernet? Think about the trade-off between responsiveness and reliability. So for a smart lock, what's more important to you? That you have low latency or reliability? Reliability for me. Like, I'll wait a minute as long as the door opens, right? And then pick the stuff that's compatible with what you're already on, right? If you're a home assistant house, then make sure it's compatible with that and make sure there's integrations. If you're just getting started, I think having a smart plug for basic on-off control of a dumb device is a very easy way to get started. Okay, so now you have sensors detecting all this stuff and actuators responding to all this stuff. What's actually running your automations? So a ton of smart home projects don't need a full-fledged computer. Really depends on your power requirements, the cost, how much processing you want to happen locally versus in the cloud. So for example, if you're working with AI, there's hardware accelerators that you can use. So the top one there is an ESP-S3, which is optimized for AI processing. Raspberry Pi recently released a hat using the Halo accelerator. And if you're doing something like Frigate, which we'll talk about next for NVR, you can use a Coral TPU as your hardware accelerator. So let's take a look at Frigate. Any Frigate users here? Yay, surveillance. Nice. So this is an open sourced NVR. You can run your security cameras with locally processed AI, right? You keep your stuff local, it's processing local, nothing leaves your local network. You can actually run everything locally. Actually, on the latest recommended hardware, that's a B-Link little mini PC. This is the recommended hardware by the Frigate docs. You can actually run this air-gapped on a local network. So if you have, like, I think this is a Hikvision, say this was manufactured in China, your stuff, when it's connected to the internet, is always talking to the manufacturer, is always getting the latest firmware updates or doing whatever you want. So you can actually have this on a completely air-gapped system. Another example is running AI locally or at the edge. So this is VM, the company I work for, where you're deploying an existing open model locally on a Raspberry Pi. So this is, I have two Pis there because one's running Home Assistant and the other one's running the AI, but you could have it on one. And I also have a hat there, but you don't actually need a hat. But this is running TF Lite, or I think it's rebranded as Lite Art Runtime, RT, using COCO, Common Objects in Context, to detect people. So now you can see this creepy person lurking in your yard. That's my coworker. He's not creepy. That's Nick. He's great. So here's a hybrid approach. If you want to train a custom AI model, in this example, I want to refill a bowl when the bowl is empty. So you can use a camera to collect all this data, and then you tag each image as with a tag of empty or full. The training actually happens in the cloud, but the inference can happen locally. So here, I deployed the model to run locally on a Raspberry Pi. And if the camera is like empty, then the motor will turn on to dispense more snacks. So you have a choice at every step along the way. And in some cases, you can run super simple automations with just a sensor talking to an actuator. You might decide to add a computer to process data locally, or to work with one or more cloud services for more control. And if you're working with AI, mostly you're training your models in the cloud. I don't know that many people that are looking to train locally. And then either using that cloud model or then deploying it to run inference locally. All right. Oh, we're doing great on time. All right, so knowing what we know now, how can we make smarter automations? Okay, so one example, my not creepy teammate Nick, instead of receiving notifications that someone's in my yard, I can't do anything about it, I'm not there, or now I have to go, I see it, but like now I have to go take manual action. Instead of that, you can detect a specific person to either allow access through a smart lock or raise a barrier for a parking garage. You can detect a raccoon and then sound an air horn. I have raccoons in my backyard, which is why I keep thinking about my backyard. Here's air quality, right? Instead of just logging the spikes, trigger your air purification system directly, turn it off when it drops down below threshold again so that you're not just wasting power, and identify the root cause of fluctuations. So I run this air quality monitor in my home office, and I saw this huge spike, kind of like the spike we saw yesterday, but I still don't know what that is. And I was like, what is this huge spike? I bought a new pizza oven, which was outside, which is great, but I have single pane windows, and I didn't even realize that pizza ovens cause PM2.5 to go up. So, root cause analysis. All right, here's a leak detection one. I am a homeowner, so I also care about water damage. But again, if a water pipe busts and you're not home, that does you no good. So you can automatically actuate something to be a little bit smarter. And actuation just gets smarter when you stop thinking about it in binary. So thinking beyond just on and off, again, it's going to be leveraging your sensor networks, the inputs and the outputs. So if you want to know if somebody's in the room, we already talked about wave for presence detection. You can use computer vision to say, is that one person? Is it 3 people? Is it a cat? What time of day is it? Do I need to turn on a light? Is anyone expected to be here? What is the detected light level? What is the temperature? And once you gather all that data from your sensor network, you can then respond smarter. I was just trying to think of a different example, but like, if 5 cats entered a room, what would you do to automate, right? So then I was like, I would turn on the lights, but to a very dim setting, because cats are crepuscular and they prefer that. I would raise the thermostat because they like it being warm. And then I would immediately trigger all my HEPA filters because anybody coming in after that would just need a little bit of clean air. Okay, so now you have a little bit smarter of an automation. And the technology has changed over the years. And right now, AI is having its moment, but what's next? So models are getting better at anticipating the needs by, similar to the nest, by predicting actions based on your patterns. And we'll continue optimizing AI at the edge. And with Matter, hopefully, fingers crossed, we'll see a little bit more interoperability. So I'm going to close with 2 final thoughts. Is how you can avoid being overly reliant on cloud services. When you depend on cloud for everything, cloud has its time and a place, but when you depend on cloud for everything, that means your automations are vulnerable to downtime and privacy risks, right? So you can use platforms like, I think everyone knows Home Assistant, ESP Home, open source ML models to keep control over your own data. You could take a hybrid approach, right? A lot of people are like, well, I can't do it because it's cloud. You can train in the cloud, but then deploy locally so that all of your data is still processed locally. And then think about local protocols so that when your internet's out, you still have connectivity, you still have activity. And the last thought is the smartest home is one that you control. And I've talked about almost all of these already, but the last one, is a lot of talks. I think there's a whole track here on AI and how to prompt AI. Is a lot of talk going on in industry right now, but like, how many people use like a co-pilot? How many people use like an AI to give you code? Yeah, I would have thought everyone in the room. But like, I literally have a mandate at work to use more AI tools, right? So AI will definitely tell you how to implement something, but how do you know what you want, right? And so knowing all the parameters, knowing all the trade-offs, knowing all the choices that you have to make will help you make a more aware and context-accurate prompt. Oh, and here is that, if you're interested in trying out any of those demos, I have QR codes for those. I think I made all of those except for Snack Dispenser. I trained the model, and in fact, Snack Dispenser is just a pet feeder hacked with a Raspberry Pi. I think what I want to do is, instead of looking down at the bowl and refilling it, because I don't need help eating my snacks, I want to turn the camera to look at my dog Lucy, and then train her that when she does sit pretty, she gets a snack. So that just takes a little bit of training on the computer vision side, but also the actuation side. So right now it's kind of like a turnstile. She doesn't need that many snacks. But if you guys saw this recently, a pill dispenser, how would you do a pill dispenser? Like a hole traveling through a thing, right? Maybe a vibration sensor when one pill drops or one treat drops, right? So lots of choices. Is there Q&A? Okay. Any questions?
Raise your hand, I'll bring you the mic so it ends up on the recording.
Oh my, you guys. Oh my, can you guys see that? Is it me? I am respiring.
Could you speak to the millimeter wave sensors? I haven't actually tried them yet, so I don't know.
I'm so sorry, I can't hear you.
Oh, can you speak a little bit to the millimeter wave sensors? I haven't actually used them yet, so I don't know what their limitations are. And
Yeah.
what they can do as well.
So millimeter wave, oh, this is such a good story, but like millimeter wave technology, like a lot of things, is not new technology, but it's only become used in home automation probably in the last 4 years, I want to say. So it's teeny tiny little waves, it's radar technology, what bounces back, generates 3D point cloud, and it's so precise, and it depends on the model of sensor that you get. The one that I was using is very good for presence detection, but I paid a little bit more, like 3 times as much, and I have one for fall detection. So it determines the speed and velocity of motion. So if somebody, goes down real fast, that's like a fall. It's good for sleep monitoring. So people will mount it on their ceilings and just monitor your sleep. It's pretty neat.
I found it does have limitations, like you talk about the light goes off when you're not moving. I have one set up at my computer, and I'm sitting there, and there's probably 20 different parameters.
Yes.
And I'm still trying to find the right parameters. I'm sitting there, and the light will go off.
You do have to tune it, so thank goodness
the
for the
tuning,
people
yeah.
that create these libraries. I found a really good library that I used it with Home Assistant, and it came pretty well pre-tuned, but even things like maybe pointing it in a different direction or identifying zones, that's all done through code. And so unfortunately, unless you want to write your own library, thank goodness for the people that write these libraries.
This isn't a question, but a comment on the presence detection. I've been doing home automation for a while, and a couple other techniques are that if you tend to carry your cell phone device with you at all times, you can actually set something up that will detect the presence, either Bluetooth or Wi-Fi bounding, from your cell phone, and identify that you're home, or maybe if it's low range, the specific room you're in, and that's very reliable, including maintaining presence even if you're sleeping and taking a nap. The alternate way, that one detects your Wi-Fi access point or a Bluetooth thing bonding with your phone, but you can do it the reverse direction too. So they sell cheap Bluetooth low energy beacons that you can mount. You'd need to run an app on your phone that would
That's
detect
called
that you're in range of the beacon, but
Sensor networks,
yeah.
more data.
Any other questions?
Expanding on the millimeter wave stuff,
Yeah.
can you actually see around corners off of?
So the one I have is kind of like a base model. It's LD2410C if anyone's gonna go out and get an MM wave sensor. That one can see through thin walls. Yeah, so probably drywall, correct, yeah. So if it's it's not like Superman seeing through lead walls.
Yeah, I just got a toilet around the corner, right? And you can't get a good spot for a sensor, so thought about
but it's so cheap. You just get an MM wave sensor, or you just get millimeter wave sensor, you get an ESP32, and then you plug it in, like, it's so cheap.
There's a couple other things if you're really a hacker and you want to repurpose devices. They make very good presence detections in the form of burglar alarm sensors that you can buy, and they were made to integrate with like UL listed alarms. But you can go get those used off eBay, and what they have in them are typically both infrared and microwave simultaneously to reject false alarms. The ones that say they reject pets are usually doing that technique. So they require a positive detect both in the infrared spectrum, and they'll send out a beacon of microwave that comes back and detect that as well, and they both have to be there before they'll trigger. And used on eBay, you could find those things for 40 bucks. Now, they're used to talking to their device, but if you're a hacker, you can probably find a digital on-off in those and wire them into something that would send it to your home automation. And they work pretty reliably. If you really want to go even another level beyond, which you probably have to fabricate your own electronics, but you likely have 2.5 gig Wi-Fi. You know, the old ones were 2.5, the new ones are 5, but most of the 5 still send for legacy purposes on 2.5. That is the same frequency as microwave. Water absorbs it, meaning human bodies absorb it. So you already have broadcasters, maybe multiple in your house, and you can put receivers that will detect the bodies, and it's possible to build devices that will even create a map of bodies are present in these rooms. I believe that undisclosed, some of these home automation commercial products actually are doing it. There's been privacy complaints. I'm not going to name any vendors that some of these are actually tracking residents of the home by room so that they can identify when you use a set-top box what individual is there. They even have, if you tear down some of these, they have a surplus of receivers in them that clearly would have no purpose but triangulation. And that could be done by yourself too, if you cared to.
I'm so glad we have that soundbite of detecting the bodies.
So you can use it without the alarm, the Ring alarm system, so.
Good to know. I went to a Home Assistant meetup, and we all raised our hands on who was using what protocol. Not a single person, I think not a single person was on Z-Wave anymore. Not to shame anyone if you are on it. It's very good.
I don't know, I'm a Z-Wave fan myself. I've used that and Zigbee, and the Z-Wave is, in my experience, far more interoperable, but the brand of it matters a lot. Like, some of those things are far more reliable than others.
All right, well, thank you all for coming. Please, I'm going to be checking and giving away the raffle, and then ship it to you. Hopefully you have fun. It is a lot of fun.
Okay, why don't you join me in thanking Joyce for this great presentation.
Oh, my.
They have a live cast on YouTube, but it ends up being available after.
No, not really, not that kind. It's a suite, a software suite. So that's the first thing to understand, and it operates like one. There are a few separate components that can interoperate with each other, but it does feel like you're using a few different programs that are coordinated and work together. So, in my opinion, much more than, say, like LibreOffice is a suite. That's a collection of separate programs you might use for something that each for its own purpose can cross over, but no. KiCad is a lot more integrated, so yay. It actually is like candy, because you get all these different things that play nice together. So covering what does it mean that KiCad is a software suite? Well, as it describes on its homepage, KiCad EDA is its full name, is a cross-platform open source electronics design automation suite. So if those words mean something to you, good. You're ahead of the game. If you're not familiar, that's fine, but what it is, it's cross-platform is one of the key things I like. So I can jump from my Linux box, I can reboot into Windows, pull it up on a Mac, I can run it everywhere. Plus, they also have Docker, which is mainly intended for command line integration kind of stuff, but if you wanted to deploy something to the cloud that does some of these operations, they have a Docker image for you. So it's Windows, Mac, Linux, and cloud. If you know how to do that, you'll appreciate that. Now, first, I need to do a public service announcement. For my personal recommendation, don't get COVID. Because I had a problem. At the beginning of the year, beginning of January, I was like, okay, time to dig in, check the current state of everything, get some actually PCBs manufactured, get stuff out. I got COVID. And it made me stupid. For work, day job, took a while to recover. So try not to do that. Unfortunately, that disrupted my planned cycle to have physical manufactured PCBs in hand. However, that aspect of it, I think, is so well proven nowadays. Just go on to YouTube and you'll see you can find all sorts of people who have made PCBs and had the manufacturers from a service bureau with KiCad. But yeah, I don't recommend COVID. Okay, moving on. So the main points is we're going to have two main steps, is how I've summarized it. And there are two main concepts. Get those down, and it's simple. Everything else is just details. If you take a simplistic view. So the two main steps when working with KiCad, you're going to be working with a schematic and working with PCB, so the PCB layout. Two separate steps. You don't have to. For example, if you're just somebody who wants to record their Arduino projects or breadboarding or anything like that, like even mini breadboarding, that's one of the things I did with KiCad a whole lot. I'd throw a breadboard layout in, put my components, save it that way, export it so that I had a record of what I had designed. Never went to PCB manufacturer. You don't have to. But if you want to, it makes it easy, especially in recent years. It's gotten so much better. Going along with that, we have two main concepts. You have the symbol and the footprint. So who's familiar with those terms in this context? Maybe a quarter of you. So not bad. I was hoping this was useful information. For those of you who know it, you already know it. For everyone else, it's new. So in general, that's what you need to know about to use KiCad. You're going to make schematics, you're going to maybe lay out a PCB, you're going to use symbols on the schematic, and you're going to place via footprints on the PCB. Kind of simple, right? Is it simple enough for me to try this at a conference? Live? Sure, why not? Because for me, I could give static screenshots, pre-canned things, but that doesn't convey the product itself. So let's try to run a live demo. So now, oh good, I am mirrored. So we see there are a few KiCad programs in here, but this one right here, the blue, is your main entry point. And I prepared some things in case this goes wildly wrong. I should have something to show at least. But let's say I'm going to start a new project. And SCaLE live, yay. So first of all, can everyone see this? Okay. It's a little bit dim and a little bit smaller, but I'm going to, the positionings where things are. First of all, you go to make a project. There's a few icons along the side here. Now, first and foremost, look to the help menu. Not sure if you can see it up here. It's a little bright in the room. But the second item here, getting started with KiCad. A whole bunch of things come up. So what this does is bring you to a local file version of their pages. And in it, it walks you through all the basics of all this, of a tutorial. So start with this. If you're unfamiliar, start with getting started in KiCad, which is second item here in the help menu. It's actually helpful. Now, if not, I'll go through and try to actually do that now, roughly, and kind of explore a little of this as we're going, what's it going to do in all this for you. So first of all, we have these two sections are created, these two files in the project. It's project-oriented. It's going to do it in a folder. So it's going to do a schematic file and a PCB file. So let's double-click on the schematic. Here it is. Most of the tutorials say to fill in the information on your project first, so when you open this, you get the title and company. And if you're a CAD person, if you're used to doing this kind of thing, company's important. You're used to all that information. If not, you don't have to do it. Ignore it. Then the essence here, we have a few empty trees, lots of tools and options, and placing. Place is one of the menu items. Place is where you're going to probably get started. And if you notice, if you can see in the menu, if not, I will tell you, a lot, like all of the top items have a single letter hot link right after them. So you can do these things, wires, buses, symbols. But let's just start with a symbol. Now, one of the warnings, though, would the very first time you bring up KiCad, it may have nothing, no symbols, no PCB footprints. It's going to need libraries of those. You can get libraries two main places, three. One, from KiCad themselves. The project makes things available, so the first time you pull it up, it's going to ask you as a default, grab these libraries and tell it yes, and it will get you a default set of libraries. Two, you can get them from manufacturers. People who make components, people who sell components, a lot of them will have these library files available, because if you pull their library assets into your program and you design with their components, you might buy their components. So it's a win-win there. And also the manufacturers. So there are service bureaus who you can send your plans off to, and they will manufacture your PCBs and send them back to you. I mean, back when I got started, you had to do copper boards, black marker, etch it with acid, try not to spill dangerous liquids, all that stuff. No more. Now you just send it off, it comes in the mail, just like Amazon, nice and easy. So they often, too, will have symbol libraries, footprint libraries, others available. So that's the second sources is from the vendors. Third source is just open source. It's open source kind of thing, is anybody might put something out. There's a lot of small libraries up on GitHub and GitLab and other places like that. So you can go and get your symbols. Then once you get them, now you're set. You have your libraries populated. So what can you do? I'm going to hit the A key. And if you did not see, there was a brief pop-up where it said loading symbol libraries. Let me try to mess with my system while it's running. To see if it's a modern computer. There, is this any more legible? Good, okay. So always depends on the projector and the lighting in the room and everything, which one works better. But here, let me hit escape to cancel it. Oh, I have something there. Let me hit escape again. You see the cursor has a little symbol attached to the cursor. I hit escape, it doesn't anymore. Okay, go back to A, because it wanted me to place something. Okay, I'm going to design a circuit. First question I have, it needs power. How's it going to use power? Am I going to plug it in, or am I going to use the battery? Let's see battery. So I'm in the search window at the top. I type B8, there we go. A couple of options for batteries. I'll go battery cell, maybe. And then down, there are other options, and this just pulls me into the middle with the most likely candidates. So I'll go to battery. Oh, that's tiny. I can't see anything. What do? Go over to it. If you have a mouse, scroll with the mouse wheel. That'll zoom in and out. There. That's a battery. Now I can see that's a battery, right? Okay. And then I'm moving it around by middle clicking. So I'm clicking my scroll wheel on my mouse. Or I could right click. So zoom in and out, scroll around. That's going to be how I'm navigating, at least. You can do keyboard if that's your thing. But those are the main navigation things here. Zoom in and out. So zoom out, get to where you want, zoom in. I could look at the title and the file, but I don't care. So let me come back to what I'm doing here. I got a battery. What am I going to do next? So if I click again, it's going to do the last action, which is the A key I typed before. I didn't have to type this time because it's still in that mode to add a symbol. I don't want a battery. I already have a battery. What do I need? LED. Ooh, and look, there's basic LED, and then all these others, series, pads, RGB in a 6-pin package. Ooh, that's fancy. So you do have, as soon as you've got the default symbol library, which you want to let it bring in on startup, you have a lot of options. Nowadays, that's a big thing. Even like 5 years ago, it was a lot harder. You had to design a lot of your own footprints and symbols. Now, either they're already in the library or they're easy to download. So let me just go with the basic LED for now. Say, okay, I put an LED here. Make that a little bigger. Anyone in the back able to see that symbol at least? Okay, at least somebody can see it, good. So then, if I hit escape, I'm not placing things anymore. the cursor changes. I can draw a wire by hitting W. I hit escape. So if I hit W, it starts doing the operation. If I hit escape, it cancels the operation, but if you notice, my cursor stays in this green line mode. So it's still in that mode, so I can do more stuff if I want. Otherwise, I can hit escape to cancel again. But in addition, components will have this little circle at the end, and if you see, when I move over to the circle, it changes into that wire symbol. So if I just move to the circle, click, now I'm making a wire. Yay. That's how you do a circuit, right? And, oh, I don't like this. This LED is not in the right place. How can I fix that? Well, if you knew, hopefully if you knew you weren't in here, because that's what I'm going over. Move over the item. You can select it if you want. There. Now I've got the whole thing selected. You can select just the label and move that, but let's get the whole component. Or if I'm clicking over here to unselect everything, move on top of it, and then I hit M. Now I'm in move mode. You can see the cursor has the little up, down, side arrows, and the symbol I was on top of is being moved right now. So that's all well and good, so I can position it, say if I want it to go along here, except I don't want it pointing at my battery. I want it kind of going the other way. Hit R to rotate it. So while it's being moved, and by the way, once I started the move, I'm not holding anything. I'm just moving the mouse. Really easy, low stress on your fingers. It makes it handy. Okay, so when I clicked again to place it. So now I have it looking better. It's along this line, which doesn't really mean anything, but it might. If I set my grids up, which is an advanced thing, you could set all sorts of things on your grids. I'm going to ignore that for now, because we'll just go with some of the defaults. Then now let me click on that circle, pull up, over, click there, click in this circle. Yeah, I've got a wire. Of course, I want to actually connect it up to my battery all the way. There's a circuit. Am I done? Anyone see a problem with my circuit? Oh, yes, I need a resistor. I wanted to point that out because an LED is one of the simplest circuits that, anyway, you give it to your 8-year-old, they want to make a circuit. LED is perfect for that, but you have to know to put a resistor on it. Okay, so I need a resistor. What am I going to do? I'm going to hit A to add. I'm going to just type, hopefully not typo it. Thermistor, is it? Oh, just so many, as you can see, there's so many options in here. Like if you know the type of component you're looking for, you can find its name, you could type that in to search for. As you can see, there's so many different options, but I'm just going for the simple R. It's a resistor. Hopefully they'll do it. But you know what? I don't like that one, because that's not what I'm used to for a resistor. Oh, look, RUS, which is the ANSI standard zigzag. Okay, that I'm comfortable with. So you can pick, they have some options in there in the libraries. They have you covered, whichever one you want to prefer. So I'll go with that. Now it's moving. I haven't clicked yet. And I realize now I can either put it here or here. I'll put it up here. So I want to rotate it, hit R. Oh, I'm not sure of the most efficient way to do that yet. It's an advanced thing. So I'll move that wire away. Hit M to move this down. Yeah, I'm right about there. Then I'll connect its wires up by clicking in the circles, moving it over. There, am I done? No. I picked a generic resistor. I double click on it. I'm getting the text value because I double clicked on the, see, I double clicked on the label. You can change the label. This label, maybe it's R7 by this point. Sure, change it. But I want to change the resistor itself. So I'll do that again. Go to the middle of the symbol where if I click on it, it selects all of it. And just double click there. Now I get some bigger things. More choices. Yeah. Ooh, advanced thing. He wants to get the right resistor. We need to know the voltage on the battery and go from there. Well, we could do that. I'm going to ignore that for now. But, oh, sorry. I was just wanted to show, also, you can move over to an item, right-click on it, and you'll get a pop-up menu, which gives you a lot of attributes, including exclude from simulation, bill of materials, board. If those don't make sense to you for now, ignore them. Later, you'll probably recognize more. And we're going to skip this for the moment, just trying to get straight to the simplest. But, oh, one of the things maybe is helpful is if I add some power. So if I hit the letter P, it's going to want to place a power item. I can open that up. And here is where I can specify something about a specific voltage, do this. But I'm not quite to that point yet, because I don't know what resistors, what battery, what LED I have. I don't know. VCC. That's a general one. To say, yeah, this part of the circuit is where power is coming in. And then let me hit P again. And then the other thing I know I need is a ground. So if I want to designate this well, I do a ground and say, okay, this part. And I know this is the source power because the plus on the battery symbol tells me. So kind of give it the right thing. And if you see, since I'm still in the adding mode, to place a symbol, it keeps popping that up. So until I hit escape. Now I can click anywhere else. So in theory, this, other than the specific values for the battery and the resistor and whatever else, this is in general one of the simplest circuits you can do. No switch, no fanciness, no states changes there. So then let's look at what some of the options across the top are. Navigation for viewing, back, forward, you can mirror, rotate. Symbol editor, if you know what you're doing and you need to get your symbol and it's not already in the library. Symbol library browser, so you can do advanced stuff and pull in more. Footprint editor, if you need a footprint, which we're going to look at soon. Annotations. Electrical rules checker. This is the handy one. This is the simulator in here. Simulator and rules checker, these two. The simulator might be a little more advanced, but the rules checker will give you some basics. Run ERC. input power pin not driven by output power. So, but and you see here, it doesn't like what's going on here and what's going on here. It put these little markers on. So not only does it tell me, oh, there's something going on there, it says, oh, right here. And I can select which one, where the problem is. So that will help you if you want to check and find out what's going on your system. I'm going to delete all markers and just ignore that for now. Some of the tutorials we'll cover in. There's another power symbol you used to have to put in. But again, this is version 9, just came out, I believe February 20th was the official release. So just as I was thought I was done and all set with practicing in examples, boom, they put out a new version. So I had to uninstall the old one and put in the new one. No, but given that, so the general flow is you run this checker. You can run the simulator if you want to get some advanced things happening, this SPICE simulator. And by the way, if I check my desktop environment here, these are showing up as separate windows, separate programs. So this is kind of the aspect of the suite going on here. And if I hit Alt-Tab, I can go between all these. Oops. And where this, so know about the simulator, look up a little quick tutorial on just that if it's something you might want, but that's not the first thing you should do. Next thing you might want to do though is go to the PCB editor, which is this green with lines in gold. I click that. Yay, I'm in an editor. Now what? It's kind of all dark and faded out on the background, hard to see, because there's nothing there yet. So up here, there's a switch to schematic editor button. Oh, okay. I'm back here. I know my circuit. Here, there's nothing. What happened? I thought I made a circuit. You want to come back over here, update PCB from schematic. I've got errors. I don't care. Do it. Yeah. Nope, those were fatal errors. Oh, it says it can't do anything. Why? Because again, I got errors, I close it, I'm not seeing anything. Why? Let me try again. Let me actually look at the errors this time. Oh, no footprints assigned. So it doesn't know what those should look like. I had picked the generic entries intentionally so that they don't already have footprints associated. So we can go back and say, oh, if you have that happen, what do? Right under here. Or there's assign footprints under tools, which took, if you saw, it took me a minute to find and drill down and everything. Guess what? That's a common thing. What's right here? Assign footprints. And if you can't tell from the distance, the icon is the symbol and the little chip footprint kind of icon together. So there's the symbol icon plus the other icon. There you go. Now I can fix a few things. So what I see here is the footprint libraries on the left, my symbols that I've used, battery, resistor, and LED, here in the center, and then filtered footprints. So if I click the battery, I don't know, but let me try. If I say battery in the search box, or just the first 3 letters. Make this a little bigger so I can see out. Oh, wow. Look at all these different batteries holders, all sorts of kinds. Panasonic. Let's try this CR1225. Okay. So I've assigned something. Should I check if it worked? Yeah, let's see. So again, I switch to the PCB editor, then I go to update from PCB. Update. Oh, still have errors. I guess I should look at those errors again. Oh, 2 more. No footprint, so it can't do anything. Okay, I guess I got to go back and fix that too. So again, see, assign. So for the LED, let me just add in the search box. LED. Now, most likely, when you're doing this for real, you'll have something, a specific LED already, not just generic, I want a place order, unless you were doing a high-level design of your circuit and now you're trying to do it concretely, which is, I was doing very high level. So I'm looking at these and I'm seeing a whole bunch of SMD, which is surface mount, which I know I personally don't want to try to mess with. This isn't the simple way to, you can do that yourself, but it's hardware. And then THUT, THT, through hole. So let's try this one. See if it works. Oh wait, I forgot, while I was there, LED, and there's all sorts of oh, wait a minute. Here's a simpler one. I'll go with this 3 millimeter. Sure. Double click on it to assign it. Ah, that's why it disappeared. And then this resistor. Ooh, lots of resistors, and again, a whole bunch of surface mount components, which I don't want to be using. An array, nah. Axial. I don't know. I don't know if what anyone's favorite resistors are, but, and it will be what you have on hand. So if I come back here now and update PCB, ooh, I had more problems there with the specific ones. Some battery issues. So this is where I'm going to come into this one I pre-made. So we can see, so now this is one I tested to make sure I have things that work. So here, a Panasonic CR2032, very common battery. This LED, which is maybe tricky. I did pick an SMD. Just for variety and through hole. So this circuit, which is pretty much what I just did, showed you how to get to. Let's come over to the PCB editor, import, update PCB, and at this point, no errors, no warnings. Because I picked these that have no problems. By the way, if I go back to semantic and look over here, we're going to have the check. And we just have those two issues that were flagged before, ignorable. PCB, here you go. And then if we look at what I have here, I've also put a couple holes in my board, just for mounting holes. Now, once you have things laid out, and I've drawn the wires between the components, so I have an LED, a resistor, and the coin battery. Then, if we come over to the 3D viewer, which is this icon over here, a couple over. So right next to update PCB from the schematic is 3D viewer. Doesn't look that much different, except you can grab it and rotate it. So now you can say, oh, okay, that's what my circuit looks like. And for a simple circuit, sure, that looks like it's enough. So let me close the 3D viewer. And now at this point, you could export the proper files to send to a service bureau to print, or to have manufactured, sorry, not print, I'm 3D printing thinking. And if I check the main app, go into the plugin and content, oh, good, it connected this time. Depends where I am. But you go to the main interface, you go to the plugin and content manager. Oops. Let me drag it taller and bigger. Allows you to do several things. There's a lot of plugins you can get by default. You can add more sources for your plugins. But what I wanted to highlight here first is what fabrication plugins. And at the moment, by default, Connect Up Live, I get 8 different manufacturer fabrication plugins. PCBWay, Sierra, HQ PCB, NextP. So these are all companies, you send them the files, they'll make the board and send it back to you. And there are extensions here in KiCad to make it easy to just pull it over and do that. So if you're looking at a manufacturer place, this is probably one of the simplest ways to make it happen. Gerber files tells it how it's going to make this board itself. There's some other files you can do, and you can even have them place the components and everything else if you want. So I was showing that so that you know you can do that. So file, you can always export. Under export, there's also fabrication outputs. So you can do Gerber drill files, so you can get your holes in your PCB correct. Bunch of others, bill of materials. But what I care about now is CAD. Export, I can export this as a CAD file. Step, I know step. So let me give this a weird name. Foo.step. Success, yay. So I'll close that. And then I'm going to pull up FreeCAD. Is anyone here familiar with FreeCAD? Quarter of you, but you want to. It will get you going quickly, but you can do, I do all sorts of 3D printed designs and other stuff with it. But let me say new, and scrunch down here a little. Get this a little over now. Okay, file, import, and my test, hello project, foo. There we go. So it's a standard CAD file you can bring into any standard CAD program. And then once I have it here, by the way, it's handy because it actually exports these components individually, so I can hide it if I don't want to be looking at it. But now, let me see if I can speed run something. Make a body. Oh, wait a minute. Okay. I had something selected when I did that. I'll just ignore that. Let me do a sketch. XY plane. Rectangle? Okay. Close. Oops. I'm bumping it down a couple millimeters. Oh, wait a minute. I'm down a couple millimeters. There we go. Use negative. Then in FreeCAD, I pad this. I've got a block. That doesn't look so helpful. Select this. Oh, wait a minute. Say OK. Select this. Say thickness. Oh, and I just hollowed it out. There. I've got a case. Well, almost. Let me do another XY plane sketch. Yeah, close enough. And my holes are rough, so, oops. This is not a FreeCAD session, or tutorial, so I'm not worried about that. But I am just showing one thing, is that when I made these holes in my circuit board, I did not measure and place them. I just randomly dropped them. So they're not all even. That is why I could bring it, as an illustration, I could bring it into my CAD program, see where those holes are, and then fix it this way. And then sketch -2, and then if I pick that sketch and then pad it, there we go, I've got posts in the right place. So by exporting my circuit board design from KiCad, I can bring it into any other CAD program and design a case to go around it and have it physically referenced there so I could see, oh yeah, it's there, and let me put the chip back, or the resistor back. So I can see, oh, that is the right place, the right things, do the right cutouts, and do all this, and then 3D print this. And then there's a secret. Remember I mentioned those 8 different fabrication plugins so that those different manufacturers will manufacture your PCB board for you? Several of them also do 3D printing. So you send them the step file from the CAD that you just did of the case, they'll make the case and send that back to you too. So, I mean, it's simple. I mean, you as long as you pick the right symbols, of course, and everything. And then, oh, check your rules. Like checking my design rules here for the PCB. Wow, shocking. I didn't break any rules. This might work. And a manufacturer might have different rules, or you might set up different rules for different projects. That, again, that all should get you going in tutorials so that you can go to a tutorial on YouTube or anywhere else, walk through it, and have a chance of actually pulling it off. But I say, KiCad makes it so easy, though. If you want to design a circuit, it's easy. If you want to lay it out, it's easy. If you want a professional company to manufacture it for you, it's easy. And I think ballpark, I was seeing some that like $5 to make a one-off circuit board and send it back to you. I remember when it used to be 10 times that. So I have not even gone comparison shopping and pricing and saying, oh, if I get 3 of them or 5 of them, is it cheaper or more or less? Or, you know, you can get deals and coupons and whatever else. So hopefully that tells you how to get going with KiCad. And by the way, yes, here is in this project I did previously to make sure it work. I export GBR or Gerber files. So it does all these different, the silk screen, paste, cut mask, copper, all this. Then drill files so that it knows how to drill the holes. I mean, I didn't have to know any of that. KiCad did it for me. So I just, if in theory, I just take these files, put them in a zip, send them off to the company, send them $5, I get my board back in the mail in pretty quick. But again, remember, help and getting started with KiCad. Oh, that's help. Getting started in KiCad. That's what you want to do. That's what you want to step to next. And then go and make something. Okay. Any questions? Oh, are there plugins? Yes. They have several sources, and then other plugins you can bring in directly from whoever published them.
Are there any plugins that automatically submit it for fabrication?
Yes, some of them do. Yep.
Just a quick question. Do the manufacturers that you send the PCB board plans to usually give you quotes, or is it kind of like a flat rate for just like the general size of the PC board?
Do they give you quotes, or is it, yeah, no, it's quotes, it's by details, and if you do multiple circuits on there, they might charge you for individual boards, even though it's physically one board. Different things like that. So it's per manufacturer, they have their own rules and their own design.
Have you had any experience with like the auto layout or like optimization tools? Like obviously you had a pretty sparse design. Is there a way to tell it, oh, I want to shrink that into a smaller footprint or something like that?
I personally have not had any experience with the auto layout tools because I haven't hit that speed yet. I'm mostly doing stuff on breadboards. For one-off projects, I use these little ones. And by the way, after the talk, I've got some, if you want a breadboard, I've got spares here to remind you to do something with it. But yeah, no, they have plugins that do various optimizations and layouts, and also checking that will tell you about various things, including RF checking, which I'm not up to doing circuits with RF sensitivity yet. Okay. Any other question?
Do you know if there's any work being done on like using Gen AI in order to even be smarter about that type of optimization?
Asking if there's AI. From being a software developer and seeing what AI does for software, especially because I'm a security company person, so I work in a security company doing security software. Always have to check what it does. However, I will say the layout and patterns and designs like this are easier for AI to get right than software itself is. But I've not checked the state of the current AI on that.
Thank you.
Okay, well then, thank you very much.
hello, hello.
Maybe put the mic closer to your face.
Yeah. Hello? Yeah, that works. There are still a few spots on the front row down here if you want them. If you're looking for seats, there's still a couple down here, maybe.
Good afternoon, everybody. Welcome to SCaLE. This is Access Self-Hosted Services Security from Anywhere. Please welcome Alex Kretschmar.
Thank you. Yeah, I have the Brittany mic on today. I have some other of Brittany's features too, but there you go. Apologies if my voice cracks during this. I was on the booth yesterday all day in that very loud exhibition hall, and I don't have much voice left, so fingers crossed it holds out. So I know some of you in the audience are already Jupyter Broadcasting fans. Hands up if that's you. Awesome. Thank you so much for coming. My name's Alex. I do a podcast called Self-Hosted. I'm the head of developer relations at SCaLE, and as you might imagine, I'm going to talk a little bit today about SCaLE and how to use that to access services running anywhere securely, remotely. So this is the slide that's been up on the screen for the last 10 minutes, so hopefully those of you, some of you have already read the presentation and I can just go home. No? Okay. Who agrees with this statement? Okay. How many of you are SCaLE users, first of all? Oh, really? And you still don't agree with this statement? We've got some work to do. Okay, well, the easiest way to do remote access, of course, is to just open a port, right? I mean, what's the worst that could go wrong? I, though, am of the opinion that port forwarding is dangerous. It's of a bygone era, and it's done now only by people that don't know of a better way. It's dangerous, and you shouldn't do it. Why? Well, firewalls exist to stop people connecting to things on the other side of that firewall. In my case, I'm sat here and I want to connect via SSH on port 22 to my NAS. And my firewall goes, you cannot pass. It's like Gandalf with the stick. And sometimes that's good. But sometimes I do actually want to connect to the thing on the other side of the thing. So I open port 22 of my firewall, and then a million script kiddies find that port like that, and suddenly, why is my internet not working? Why has this box been popped? Because the trouble is, when I open it for me, I open it for everybody else too. So we end up in this wonderful situation. This is live footage from Doge, by the way. So first of all, what is a port? It's kind of analogous, really. If you think about an apartment building, you've got a street address, 123 Evergreen Terrace or whatever it is. Inside that apartment building, you've got apartments. And those have specific numbers so the mailman knows where to take things, and you can drunkenly stumble home with your key and find where you live. And there are a number of these ports available within the TCP/IP networking stack. Some of the more common ones, port 22 is for SSH, DNS works on 53, HTTP on 80, and so on. Anything under port 1024, by the way, is a reserved port and must be approved, I think it's by the IANA, International Association for Number something. You don't want to go to dinner with the guy that thought of the name of that thing. So we've got ports, and we've opened things in our firewalls, but they suck. Firewall rules genuinely suck. They don't scale. They become really, really restrictive because you can only, they're sort of like a one-to-one thing. They're not this flexible, they're not software defined or anything like that. They can't react to certain conditions. Maybe if you're paying Palo Alto tens of millions for a special box, they can, but like for most of us mortals running like OpenSense or whoever knows what at home, like it's a static thing that you defined once, and it's like, right, from this source IP, I'm going to now allow traffic to flow when these conditions are met. The other trouble is they must always go to a fixed destination. As I said, they're not flexible. They don't really scale. And by the time you start thinking about, we've only been talking about inbound firewall rules. Lord help you when you start thinking about outbound firewall rules and you turn off your own internet completely by accident and think, what have I done? So who agrees with this statement after that? Yeah, even less. Good, I've done my job. This also creates another problem. I need to know where the front door is of that apartment. I need to know what the apartment building address is, what my physical IPv4 WAN address is. Who's run something like DuckDNS or DinDNS or Cloudflare D or whatever it is, yeah? Yeah? And how often have you tried at some point to log in and it's out of sync? Yeah, it happens. So what about VMs and containers? Do they help? Well, kind of, because we can use firewall rules to target more specific things. We can run things like load balancers and reverse proxies at the end, as the endpoint behind our firewall, but they only do so much. So take this example, right? We have a pretty straightforward example of me trying to access a web service behind a firewall. I then hit my reverse proxy, sometimes called a load balancer. They are different, but for our purposes, they're the same. That traffic then spreads out. It has the permission to go out inside your local network and access the resources and serve the website to you. But they're not perfect. If somebody can still get to that front door, if somebody can still get to traffic and pops that box for some reason, they can do what's called island hopping, and they can then get from that cute little gopher to all of those cute little whales. And the problem hasn't really changed. We've just kind of we've kind of created a new problem by trying to fix the old ones without changing our way of thinking. So, I mean, containers do help a little bit because they create isolation at the kernel level. So rather than having multiple services running under the same kernel with no isolation, you've got a container that's actually basically slicing up what are called C groups within the Linux kernel and dividing processes up in memory. They are efficient. Containers in general are pretty efficient compared to virtual machines. They're not emulating an entire computer. So, like a virtual machine is emulating a CPU, a motherboard stack, a network stack, a disk stack, blah, blah, blah. Whereas a container is sharing all of that stuff with the host kernel, and it's kind of just piggybacking off that stuff. Thankfully, in the last 10 years or so, containers have gotten a lot better at security features, and they're very, very well understood at this point. And with care, I think, for the most part, containers are pretty good for most people self-hosting stuff at home. Even for large enterprises too, to be honest. EKS is a thing, and containers have, 10 years ago you were crazy if you were running a container in production, and now you're kind of crazy if you're not. So I think there's a better way, unsurprisingly. What if we could just ignore the firewall altogether? Wouldn't that be nice? This is like a panacea, right? Imagine if you never had to write a firewall rule ever again. So today's agenda, we've covered why I think port forwarding is dangerous. Hopefully you agree. We're going to now look a little bit at mesh VPNs. And disclaimer time, I am a SCaLE employee, maybe you noticed, or come and talk to us at the booth. So we're going to talk about moving beyond the firewall today. What does this mean? What does a mesh VPN mean? It means that every device can talk to every other device. And this is in stark contrast to the hub and spoke model that we talked about before, where you've got one entry point to your apartment through that front door. Well, now suddenly I've got every single orifice I can enter and exit my apartment through. It might sound like that's more dangerous, but actually it's much more secure. So let's go back to our example here of the firewall, of me trying to SSH into my home server. Using a traditional VPN, I create a static tunnel from my client device. That then connects to a VPN server running somewhere that has permission to tunnel back into my home network. I send all the traffic through that way, and for the most part, it works pretty well. What happens, though, when I want to add a mobile device, or I want to scale it to 1,000 users? It doesn't scale. So with Tailscale, rather than doing a hub and spoke model, I'm establishing a direct tunnel to the target endpoint. There's no kind of intermediary hub software. And this allows me to not only have no ports open in my firewall, huge security benefit, but I've also got a direct end-to-end encrypted tunnel between device A and device B. Huge win. These direct connections are using something called NAT traversal. A network address translation is essentially a way of making a few IPv4 addresses go a long way. I'm sure you're all familiar with the fact that we've run out of IPv4 addresses for a while now. This is the year of IPv6, maybe. Or is it the Linux desktop? Kind of confused. It changes. So NAT basically allows you to have one public IPv4 address and then have multiple clients on a subnet behind that, effectively. And then those clients talk to the NAT software running typically on a firewall, and they figure out a bunch of stuff in the firewall called stateful firewall stuff. And when those devices make an outbound connection, the stateful firewall remembers that connection and then says, well, if something comes back on that port, I'm going to allow it in for the next 20 seconds. And it's a really secure way of doing it. And Tailscale uses something called stun, which if anybody sails the 7 Seas and uses BitTorrent, you've probably seen stun servers before because they're in every torrent client. That's how they do the discovery. So we use the stun protocol to do discovery from our control servers, and then that handles the mapping of NAT addresses to UDP ports. These direct connections allow any device to connect to any other device, no matter of the network topology that's in the way. So it doesn't matter if, for example, if anybody here rely on Starlink for their daily internet needs? You lucky bunch. My good friend Brent lives up in the Canadian mountains, and he relies on Starlink for his personal internet. And we're on a Zoom call, or I was going to say Skype. It's a bit out of date, isn't it? A Skype call, and he'll just disappear for 30 seconds. But the trouble with Starlink is they do something called carrier-grade NAT. It's the same thing that happens with your cell phone. You couldn't run a web server from your phone because you don't have an IPv4 public WAN address. You've only got a carrier-grade NAT address, which is really effectively just a LAN on the carrier side, and then the carrier has a pool of IPv4 addresses that they'll allocate to kind of like a node that is responsible for those downstream clients. Okay, so if you want to learn more about NAT traversal, I highly, highly recommend taking a look at this post. It's a couple of years old now, but when I first started at Tailscale, I learned more than I thought I didn't know how much I didn't know until I read this post, basically. Go read it, you'll learn a ton, and it's a really good one. So we're going to talk now a little bit about running local services. Look at my humble home lab, sat in the basement. This is my temporary server rack that I built 7 years ago when I emigrated to North Carolina from London. I don't know if you could tell, but I'm from London originally. And it's just some 2x4s screwed together from Home Depot. And I swore it was going to be a temporary thing. But now it's still in production. It just does the thing, you know? Despite half of the internet telling me it's going to catch fire because it's made of wood. So far, so good. Who here does self-hosting? Hooray, I'm amongst friends. It's fun, isn't it? You get to own your own data. You get to lose your own data. In fact, I don't know if anybody's seen my latest YouTube video talking about this, but this presentation actually nearly didn't happen because my Nextcloud instance is running on, well, it's actually on that hard drive in that box right there. And this was last weekend. And it's running Nextcloud, and I didn't have a copy of the presentation locally, because when I submitted this was like 3 months ago. And I've had a new laptop since then. And so not only do you get to own the data, but you get to own, so when it goes out, basically, you're not calling Google or anybody else, like you're on the hook to fix it. So both a bug and a feature. One of my favorite aspects of self-hosting, though, is that you get to build a solution piece by piece. You get to craft a solution. You get to select your tooling, make decisions based on your personal, well, beliefs, I suppose, your risk profiles, your technical expertise. A bunch of things go into the decision of like choosing, let's say, Nextcloud over C-File, for example. And over time, you will assemble a stable of software that means that you never have to worry about some of this stuff ever again. Well, until your server blows up, but that's part of it. The single biggest reason for me and why I really, been doing the podcast for so long now is that there is no business model to feed. How many times have Google canceled products on you now? How much longer are we going to accept that as being the status quo? Like, I know right now Google Photos is kind of free-ish, but that's not going to last forever. And you can use self-hosted software like Image, which is a self-hosted photo and video management platform, to replace Google Photos. Now, what happens if the Image team stops developing Image? Well, you've still got a functional product as of today, and you will have that code, because it's open source, until the end of time. Should you wish to fix a bug, should you be capable, you can. Good luck trying to fix a bug with Google Photos. Same thing's true with Jellyfin. That's analogous to a Netflix or a Paramount Plus or any of the plethora of other streaming services that are proliferating these days. Another one of my favorites at the top here is this Libre speed. I actually use this to test when I run a new cable in my house, for example. A couple of weeks ago, we're having our attic turned from a dusty, dust bowl where it just collects pollen dust. We're having that converted into like a studio space for me. So I ran a fiber from the attic to the basement. I'm like, well, did it work? I mean, I don't want to do iPerf or anything like that. So I just literally plugged in a 10 gig adapter to my laptop, pulled up Libre speed, ran the test, and I got 10 gig down, 10 gig up, and I'm like, sweet. Nothing left my LAN. I didn't have to worry about speedtest.net and throttling and prioritization of the WAN and all the rest of it. That's even presupposing that your WAN can do 10 gig, which mine can't. Then there comes the juggernaut in the room. Home Assistant users? Oh, a lot of you are missing out. Home Assistant's awesome. Okay, Home Assistant pitch time. You have a Philips Hue bulb in your life, right? Then you have a coffee pot, maybe some smart blinds, maybe some other lights or something, I don't know. How do you connect all those disparate ecosystems together? You can't make a Philips Hue bulb talk to your Craig coffee pot, or Keurig coffee pot, can you? Well, with Home Assistant, you can. Because our Home Assistant has a bunch of plugins that pulls all of these disparate random IoT things into one place. And because they're in one place, They can react and they can talk to each other, and then they can start to actually build a smart home instead of just a sort of kind of worse version. When I first emigrated, I will always remember, I went to Best Buy the first week I was here and bought like a Google Home and some like a huge string light for the guest room. My mother-in-law came to stay, and she was like, "Hey G, turn off the lights." Nothing happened. And I heard it through the wall a second time. The third time was full of expletives. And it was in that moment I realized I had to design my smart home not just for me, but also for guests and other people and other humans to actually use it too. And with Home Assistant now, I've got the ability to, have like a mother-in-law is in the house mode. I can literally just say like, these light switches don't work physically except at these times, and so really you can get as granular as you want. It's all written in YAML. And I actually just on Reddit last night saw somebody who's developing an AI agent that will help you go through all of the entities in your house and say, hey, by the way, did you know these things often turn on and off together? Did you want to put that in as an automation? Because it's open, because you're in full control, not only of how the devices connect to each other, but also of the underlying Home Assistant code base, you can do some really cool stuff. So those of you that didn't raise your hands about Home Assistant, please go check it out. It's free. It's an awesome, awesome project, and I think you'll have a really good time. Now, some of you might be thinking like the barrier to entry seems really high. Like perhaps the self-hosting world is just for people with neckbeards and bodies such as myself. But actually, it's really easy. It's just a few lines of YAML. Really, that's all you've got to do. So this is a snippet of a Docker Compose YAML file. This defines an app called Audio Bookshelf. This is basically a self-hosted alternative to Audible. Now, I pay for my audiobooks, always have, always will, because I think authors deserve the money. There's a contentious argument to be had about film studios and the media business in general, but I think written stuff and like books and things is like a separate category, and it's still a little more like the author still sees more of the cash, even if I buy it through Audible. What I don't like about Audible, though, is it's full of DRM. So if Jeff Bezos decides to change the business model on me, remember we were talking about feeding business models a few minutes ago, if Jeff decides suddenly, let's say I stop paying for Audible subscriptions, and then I lose access to all of the library that I've acquired over the last decade, that doesn't seem right. All this stuff that happens in the media right now about acquiring licenses to things rather than actually owning stuff, it's not for me. So I use a program called Inaudible to download the AAX file from Audible, strip the DRM, and then put it into Audio Bookshelf. As far as my wife can tell, the interface looks just the same. She can pause and sync between different devices, and it's awesome. So when my wife goes to Audio Bookshelf, abs.wd.ktz.me, that's my personal domain, what happens? We're going to talk through the anatomy of a web request here, so sorry if I'm teaching anybody how to suck eggs, but I thought this was pretty interesting, actually. So first of all, your device makes a web request. Where does that request go? Well, step 2 is that it goes to a DNS server. In my case, that's a Pi-hole. Once the domain name has been converted into an IP address, step 3 on the client then goes out through the firewall in step 4 and creates that outbound NAT port mapping that I talked about earlier. The destination firewall then matches that traffic to a rule set that says, well, I'm going to allow traffic in on port 80 or port 443 or whatever it is. And then it's going to hit a load balancer or some kind of a reverse proxy or some resource or some kind of traffic direction mechanism that has permission to reach out inside the network you're trying to connect to grab the resource that you want. So in this case, step 6 and 7 happens on the remote side. Finally, step 8, that content gets returned back to you and you start playing your audiobook. Now, there are some specifics to be aware of with setting this kind of thing up. You've got to try and make sure, at least I'd like to try and make sure that this stuff works whether I'm around or not, whether Tailscale's around or not. And so I set up my local DNS server in each location. So I have my house at home, I have my mother-in-law's house, and I have my dad's house. And I run Pi-hole in each of those locations for them, and then I use split DNS to be able to access the services running in each place remotely for myself, but I also want the people in the remote subnets to have no idea that that's possible. I want them to just think, oh, I type this thing in and it just kind of works. So running a local DNS server in each network, which is then reachable over Tailscale, means not only I can administer that stuff remotely for friends and family, but also it will keep working for them regardless of whether I'm here or not. So I kind of thought when I was writing this talk, like, what is the most cursed thing I could come up with? And for me, it was, well, why don't I put step 6? Why don't I put between step 6 and step 7? Why don't I put that over Tailscale? So rather than having caddy reverse proxy over a local IP address of 10.42.1.10, why don't I have caddy reverse proxy over a tailnet IP instead? And this way, I can run a reverse proxy in my house, but have it reach out to a back-end server, or whatever it is, over the tailnet. Fully encrypted, remember, end-to-end device direct connections, all that good stuff. So now I can actually access the front end of my mum's Synology from my local network without having to run that DNS server in her network too. So I'm always trying to simplify and trying to figure out ways to make this better. But essentially, that was the most cursed thing I could think of, was why doesn't the reverse proxy reach out over Tailscale instead? Okay, we're at the Magic DNS stuff here. So Magic DNS is Tailscale's way of giving devices on your tailnet a fully qualified domain name. So rather than having to remember specific IP addresses, you can just type the name of the node, for example. You can use split DNS to route arbitrary requests wherever you would like. So you can see here, for example, I've got ktz.ts.net, I've got GG, which is Goldgate, where my mother lives in England. I've then got git.ktz.me, which that actually resolves to my local Pi hole, and then another, it's just like turtles all the way down. So no matter where I am, I can resolve these domain names, and instead of having to route things through 20 different spots, like, this just makes it simple for me. Okay, this is probably the most dangerous part of the entire talk, because I added it this morning, and it also requires network connectivity, so fingers crossed. If you are already a Tailscale user, has anybody actually ever used this apps button before? Just one person. 2 people. You've looked at it. You know, I've been working there for a year and a half, and I've looked at it too. Until last week, I was like, what does this thing do? So I'm an expat, right? You know, I live in America now, and I still really miss BBC iPlayer. Now, I'm not going to advertise geo blocks and circumvention stuff, because that's like Fight Club, right? You don't talk about that stuff. So what we're going to do is we're going to look at IP Chicken as a website. What you choose to do with this information, it's up to you. So what we're going to do is we're going to configure an app connector for a target domain, in this case IP Chicken. We're going to advertise on some remote infrastructure. We're going to advertise that as what's called an app connector. And then using the Tailscale access control rules, we're going to route traffic over Tailscale, but only for that specific website. So IP Chicken, instead of saying my current IP address, when I'm connected to my tailnet, it will route that traffic out over the tailnet to England and come out in England. Okay, wish me luck. I should probably mirror my displays, right? I didn't do that beforehand. Whilst I mess about with that, are there any questions at this point? Because I'll be a minute or so. Good. Okay, how's that? Good stuff. All right. So, okay, here I have an Ubuntu virtual machine running on top of DigitalOcean. This is running in London. Now you can note the IP address here of 104.248.165.82. So let me turn off Tailscale. And if I go now to IP Chicken, this is my current IP address. That was really fast. Cool. But if I turn Tailscale on, it's not configured yet, so it's not going to work. But I told you I only did this morning. I haven't rehearsed this bit, so there you go. We need to configure the app connector section here. So there's a bunch of documentation, which we're not going to go through step by step, because I've done some of the prep already. But essentially, when we click on this apps tab over here, we want to, let me make that bigger, we want to now tag some of our infrastructure to be what's called an app connector. And you can kind of think of this like split DNS, but for a specific website. It's useful if you've got an enterprise GitHub or something, and traffic has to originate from a specific spot, like enterprise security teams like to whitelist specific stuff. I like to use it for iPlayer, like I said. So let's take a look at what's involved in creating one of these things. Not much, thankfully. We put in a name, which could literally be anything you like. We then put in a domain name, so in my case, IP chicken. And then we need to do what's called selecting an ACL tag. Now, I've created a tag here called UK connector. So how do we apply that to a specific situation? Well, first of all, in the access controls tab, I need to create this tag connector here. It's only 3 lines of code, so I think we can probably manage that. Once that's done, we'll go to machines, and I will find in here, this is the pres, this is the same instance that was in that QR code at the beginning. That's what's hosting the presentation that you all looked at. I can now go in here and do what's called edit ACL tags, check the box, and I'm now going to advertise this as a UK connector. This is because on the back end, let me make this a bit bigger for you. Did I disconnect from Tailscale? No. Oh, I changed the name. Yep. I'm going to connect, and I'm not, apparently. There you go. This part of the demo is not going to work, but hopefully the end result will. So if we go back to the apps page, you can see that now IP Chicken is going to route all of its traffic through the pres domain instead. So now, hopefully, when I refresh this, this page, it's going to pull down the new routes from Tailscale, and suddenly, look at that. All of my traffic is now being routed through that DigitalOcean droplet. You see, was it 165.82? 165.82. And so if you were to get the right incantation of specific news websites that you visit, banking websites that you visit, content websites that you visit, for example, Lobsters RS is currently blocked in England. If you wanted to come out in America, I think it's still available, you know. You can do that kind of thing using app connectors. And this is just one example of the flexibility of Tailscale. You've got direct connections on infrastructure that you own. So this is just running on a droplet that cost me $8 a month. This could just as easily be a Raspberry Pi that you chuck under the stairs at your mum's house and never worry about ever again. As long as it's got internet connection, Tailscale will find a way to connect to it. Okay. Any questions on that? Because I know that wasn't perhaps the clearest demo, but yes.
I just have a clarification question. It looks like these are either route or application-specific exit nodes. Yes?
Yes.
Gotcha.
App app, what did you say?
App-specific exit nodes.
App-specific URL-specific exit nodes, yeah, exactly. That's exactly what they are. That's an even better way of putting it than split DNS for certain things. Can I steal that? Hi, Mike.
Hey, your first load, you got the DNS error. I use the app connector a lot, and I always seem to get that DNS error on my first load.
Yep.
Is that a known issue? Is that, what is?
Well, it's because typically the first load is pulling down the new rule set from the control server. And that can just take a beat to happen as it's, because each Tailscale client is running a fully local DNS copy of all the rule sets. And so when it's doing a device lookup, it's not going to Tailscale, it's just happening locally. So if the Tailscale control server goes down, I'm not sure I'm allowed to tell you this, but every time we deploy Tailscale, we take Tailscale down for a minute or two. And then most of you probably never noticed, because all the stuff is happening locally.
And DOH was a real nightmare to figure out, but turning that off makes it work a lot better.
Yeah, and the other situation where it can get a little hairy is like captive portals, if you've got Tailscale turned on, because that's messing with the DNS, and then the captive portal's expecting a certain thing, and yeah, just, it's always DNS, right? So if you want to find out more about Tailscale, I make a ton of YouTube videos for them. Obviously, I've got the self-hosted podcast, but also what pays my mortgage is, the Tailscale videos. I tend to try and do as much home lab stuff as they'll let me get away with. So I've got a really interesting video coming up in the next couple of weeks about NixOS, self-hosted AI with Olama, and NVIDIA GPUs, and how you connect it all with OpenWebUI and that kind of stuff. So go check it out. This is, again, where you can find me. And I think it's time for the big reveal. So that QR code that you all had at the beginning, right? I think I already gave this away, didn't I? But that's actually running on that DigitalOcean droplet with the firewall completely closed over Tailscale using something called Tailscale Funnel. So you can use that one command to actually host websites. So let's say you're a developer and you want to share just a quick prototype with someone. You can do Tailscale Funnel, port number, and it's on the public internet. Obviously, that can be incredibly dangerous if you, you know, like.
So it's basically like ngrok built into Tailscale.
Yeah, it's just like ngrok, but built into Tailscale. Yeah, absolutely. So I think that'll do us. So yeah, please, lots of questions. I would love to do a bit of a Q&A and sort of answer questions about self-hosting. It doesn't have to be about Tailscale. It can be about anything you like. So.
How do you handle high throughput or applications that need a lot of bandwidth, like backups or stuff that's constantly running 24/7 remotely across the ocean?
Well, funny you should ask, because when I emigrated, I left my old server in England. And then when I got here, I built a new one, because American tech prices are awesome compared to Europe. So I replicate roughly 20-ish terabytes between my server in the basement, although I realized I missed a Nextcloud data set this week. That was actually quite a scary moment. But because Tailscale does direct device-to-device connections, the performance is pretty good. So across the ocean, I typically see somewhere in the region of 40 to 50 meg. I've got, as of about 6 months ago, 5 gig symmetric fiber at home. I was really excited for it to run at 5 gig symmetric. However, the encryption overhead of WireGuard is single core bound. And so you run in, when you're trying to throw that much data over a wire, you actually gain quite a lot of performance by doing like multiple threads. So you have like a tmux window open or something and do 2 or 3 streams, and that can take you from 50 to 100 to 150, just like that. Yeah, looks pretty good.
The problems are always DNS. I've got Pi-hole that I connect to back at my house. If something doesn't load on my phone, I turn off Tailscale, turn it back on. Usually it works. And then if it doesn't work, I just restart Pi-hole and it usually starts working. What is going on in the background, on, say on a phone, when I'm turning off and turning back on the app that kind of resets the cruft?
Probably that. I mean, you've seen the IT crowd, right? Yeah? So when you're turning Tailscale off and then you turn it on again, there are a bunch of caches that get cleared. It also forces the phone, or whatever it is, to pull from the control server the latest, freshest version of everything. It's like the most up-to-date routings, for example. Because of the NAT traversal stuff, you know, you can't necessarily guarantee that all the clients are where you left them. You know, this laptop, for example, is in LA today, whereas last week it was in Raleigh. And, you know, like, if there hasn't been a sync happen for whatever reason, sometimes those things can get a little bit out of whack. Turning it off and on again, as cliche as it is, just forces that sync to happen.
So I've been happily self-hosting with the, you know, what you would call dangerous, you know, port forwarding, reverse proxy, dynamic DNS mechanism for well over a decade. Knock on wood, I haven't had any problems. I do share your concerns that it does open you up to, you know, dangers, you know, that you would not have elsewhere. But my question for you is, there are some services that I get great benefit from being publicly accessible, right? For example, my Nextcloud instance. It's nice to be able to share links with other people, say if I'm traveling with somebody and I want to share photos. Or it's honestly my disaster recovery plan in case I lose all of my devices. I can log into my Nextcloud and get my password database and get access to everything. So is there a mechanism, if I was, now I can see the benefit of using TailScale for services like Home Assistant, for example, where, you know, currently I have that publicly accessible and it kind of weirds me out a little bit. And, you know, I can see the benefit to locking it down. Are there mechanisms within TailScale for saying, I do want some services to be publicly accessible? Is that a thing that you can do?
I actually hid a bunch of slides because I decided that wasn't that interesting, but this is going to answer your question so perfectly, I think, that I'll just, I've got time, I think, right? How long have I got? How long? Oh, really? Wow. Okay, well, we'll definitely do it then. So you can kind of abuse CNAMEs to do this, right? So a CNAME is a way to kind of hack DNS a little bit to point something at something else without it actually being an A record. So what you could do is you could put a CNAME into a public DNS provider pointing to a TailScale node inside your network. So that's what this looks like. For example, I've got a caddy reverse proxy, which you can see is running on the Velociraptor Noodlefish TailScale net DNS name. And I do a wildcard entry for star.rdu. So whenever I go to RDU, or like audiobooks.rdu. Whatever the domain is, underneath, that's then going to try and route itself to a TailScale domain. The clever part comes when you're running caddy on a publicly available server. So let's say you put caddy on a VPS. Do I have a picture of this? No. You're running caddy on a VPS, and you have it in front, you have a real domain name of tethix dot something, I don't know, you know, audiobooks.tethix.com or something. And in the background, that's then resolving the CNAME because that node is on your tailnet. It then tunnels back to wherever that resource is and goes and fetches it. So the front door is moved, effectively. You're not doing port forwarding. The front door is now still on the public internet, but it's kind of obfuscated a little bit by this mechanism using CNAMEs. So if we look at this example here, for example, if we use dig, you can see that the CNAME here of test.rdu.dotsandstuff.dev actually resolves underneath to a TailScale domain, which then means I'm able to route whatever I want behind that wildcard of RDU something to my LAN. So that lets you use real domain names if you want to, like I said, the stuff that you own, because you can just use caddy's built-in Let's Encrypt support to get a certificate for whatever domain name you want to, and should be good to go.
So just to confirm, there are like ts.net addresses that are publicly accessible. It's not just a internal have your device on TailScale.
Well, you can use TailScale funnel to put something from anywhere on the public internet, and that will be on a ts.net domain. The downside of funnel for that specific scenario, Nextcloud, for example, let's say you're dumping a bunch of photos, it's quite a high bandwidth scenario. Funnel uses a piece of TailScale infrastructure to proxy all that traffic in and out, because then that traffic has to go through a front door somewhere on the public internet, right? But by you spinning up a VPS and doing this CNAME trick, you then become the owner of that front door. So you're not subject to any quality of service restrictions we put on the funnel traffic that comes in and out. Also, you can then choose a provider that's geographically best for you, and right, there's just a lot of reasons to do it yourself. Like you put some craftsmanship into figuring out the best route for all the traffic. So the answer is yes, it does involve a little bit of work, and I would love for TailScale to support custom domains. I've heard rumors it might be coming, but I heard that a year ago too, so watch this space.
Thank you.
There was a lady down the front here. Do you still have a question? She's busy in her program.
I'm sorry. Actually, my question was because I I didn't understand what you're saying. So I was curious, what did you do with that, your mother-in-law's, your house, and somebody else? You were able to go through some kind of DNS. What were you doing, by the way? I was just curious. I'm sorry, I missed that part.
That's okay.
Can you go back to that slide you were doing? Which slide?
I don't know where it is.
Remember. The one that you said you set up the, is it Pi-hole you did? I can't
Maybe.
remember.
I can talk you through it, though. This one?
No, not that one, but the one that you, I don't know which one.
Up,
but
up
you,
or down? Up or down? Which slide? I can't remember.
Oh,
Yeah.
yeah, right, exactly.
So the idea is, I want each network that I kind of administer, my parents being one of them, to be fully self-contained. So regardless of whether I am involved with it or Tailscale's working or whatever, like, I don't want the DNS requests to be going across the ocean every time. Number one, performance would suck. And number two, it's just a layer of complexity that I don't really want to be dealing with. My mum texts me saying, Alex, the DNS is down at, well, for her it's 7 a.m., for me it's 2 a.m., you know? So what I wanted to do was find a way to kind of treat each site as a unique, like an isolated entity.
Okay.
And by putting a local DNS server in each place, it allows me to have that fine-grained control of just having a DNS wildcard pointed to that site. And then for me, I can just run a reverse proxy on that network, and parents are none the wiser. Does that help?
Yeah, that's nice. Okay. Yeah, that was just something I wanted to know a little bit more. Thank you.
You're welcome.
Infrastructure, Ansible, Terraform, Nix. What are you using to manage the whole infrastructure?
Yes.
Yes, yes, and yes.
My home lab has several non-negotiable pillars. One of them is Proxmox. Another one is Ansible. Increasingly NixOS, although not completely non-negotiable because it's a pain in the ass, honestly, sometimes. Docker, and then some form of config management. And I use different strokes for different situations. So I'll use Ansible to manage my Docker Compose files, pretty much exclusively now, actually. So what I do is I create an Ansible variables file that has basically the outline of a Docker Compose file, run that through Ansible, and it will inject all the secrets into the Compose file and then copy it to the remote host. So I've got all my secrets stored encrypted in GitHub, and occasionally I forget to encrypt that file, and my infra repo, I don't know if I can show you this. I don't know if the Wi-Fi will help, but every time on my GitHub repo, this is where all that code lives, by the way. You see this 99.7? Used to be 100%. Every time it iterates down one, I forget to encrypt that file, and there was one moment where where is it? Is it in group vars or something? I forget where it is. But I got an email on my phone from Google saying, your Google password's been exposed. I'm like, oh, because that connects everything. And you know, the best part was, that was when I was using SnapRaid to do like media server stuff. I don't use SnapRaid anymore even, but there was like a program called SnapRaid Runner that used to send me email alerts. I wasn't even using it anymore, so I still have my Google password in this massive encrypted variables file. But I use Terraform to spin up things like Kubernetes clusters for videos for work and stuff like that, like a couple of commands here to just use the Terraform providers to spin things up here and things up there. Really, I view my home lab very much as a tool for educational purposes. I think, like, what direction is the industry going? Well, right now, of course, every buzzword, every paycheck is every VC check is going towards AI right now. I also have a personal interest in Nix, and so you think to yourself, well, how can I make myself more relevant going forward in the marketplace? How can I, how can I keep my content interesting to people and keep them listening to the podcast? Make interesting videos for Tailscale. It's like, well, just do stuff that other people aren't quite doing yet and figure out how to connect a few dots together. And for me, that's what a home lab represents, really. It's a playground where, for the most part, I can break stuff without too much consequence. And so you end up making a bunch of decisions about, like, separating physical hardware and, like, do I put Plex on the same box as I'm spinning up those virtual machines that can break stuff? No. I end up having, like, a pseudo prod at home, which runs Plex and the R stack and all that stuff, along with Home Assistant. And that box is called Neo, because it's the one box that must be up all the time. Because if that one goes down, my 4-year-old will tell me in about 3 seconds that, Daddy, I can't watch Peppa Pig. Whereas when my Epic server goes down, there are situations that require specific pieces of hardware, like GPUs for LLMs and that kind of stuff. And I just want to experiment. And occasionally, as you saw in that thumbnail, like I break stuff, and it's the reality. And every time something like that happens, like I tried to log into my Nextcloud to download this presentation, and I couldn't. I'm like, I need to change the way I'm thinking about this, because like the home lab should not have any critical infrastructure on it. Okay, maybe the GPU part, I can kind of get away with putting that as being like on that box, but the actual core of Nextcloud, the core of image, should probably be on Neo, right? And it's just, you can then apply those lessons at work. In my interview processes for my last 5 or 6 jobs, I've referenced my home lab. Originally I was talking about Unraid back in the day, and then I matured onto doing it with native Linux, and just the skills I've picked up in that environment make me sound like I know more than I do when I get to an interview. Really. That's it. So, got one down the front. In front of you.
I think I've heard you mention before about using SCaLE, like sitting right with a container for the one application in a container. How does that work?
So are you talking about SCaLE sidecars, like with Docker?
Probably.
Yeah. So, tail Docker. No. I'm on the wrong tailnet, so I can't currently reach my self-hosted Google replacement. But essentially, there is a whole bunch of documentation with my ugly mug over it for SCaLE. I also wrote a massively long blog post last February talking about how to do this. So, when I find the right code snippet, there we go. Essentially, if you want to put a container directly onto your tailnet and get all the advantages of having that direct device-to-device stuff, even having containers talk to other containers over SCaLE. So for a good example of that might be you've got Prometheus wanting to scrape a Kubernetes cluster on the other side of the world, and you've got pods moving around doing whatever they do and all the rest of it. If you define a sidecar in that kind of Kubernetes world, or in this case, this is just Docker Compose, you can actually merge the kernel namespaces in the network realm of those two containers together, such that they've still got individual user spaces, so each of those binaries are operating in their own fiefdoms, but the networking namespace in the Linux kernel that was sliced up for those two containers because of this line here, network mode service, whatever, which, by the way, matches the name of the service in Docker Compose, you merge the networking namespaces together within the Linux kernel. So if you were to do like a netstat or an nsenter or something like that and list the ports that are running in those two containers, they'd be the same because they have the same network namespace. And so really it's just a case of supplying the correct environment variables, authentication keys, and storing the state directories in the right place, and you should be good to go. Does that answer the question? Yeah? Thanks. Thanks, GMB.
Which service do you use for your home lab backups?
I don't use a service. I have a friend in Canada called Producer Steven, if you listen to self-hosted. And we actually racked and stacked an entire server for Jupiter Broadcasting. So he runs an MSP, service provider in the local Ontario area. I'm aware Ontario is an entire province, but anyway, north of Toronto. And he was building out a room, and he's been listening to the podcast for ages, and he reached out, and he was like, I've got 4U of rack space. Do you have a server? Do you want to just throw a server into my room? I'm like, heck yes, I do. So now I have a server in Toronto, effectively, that I have full control over, that has about 6 disks in it with ZFS, and I can just send everything there. I've still got my old UK server, remember, so I've got stuff in England too, and I replicate everything to Ontario and England. And then at my mum's house, I've got an old Synology where I send a bunch of stuff as well. None of those places had the Nextcloud data set. So I've learned some gaps today. But if you were going to be using a hosted service, there are some pretty good options. Has anybody here heard of ZFS.rent? It's about to change your life. You can send them a hard drive. I think it's like $10 a month. So if you go to Best Buy and buy a 20 terabyte hard drive, you can send that, you can pre-populate it with your data locally, send it in the mail to them. I think they're on the West Coast, actually. And then they'll throw it in a server for you for $10 a month. There's some bandwidth restrictions and stuff like that, of course, but if you've preceded the disk, you can get over a lot of that stuff, and it's by far and away the cheapest way to store 20 terabytes worth of data in the cloud that I've come across. You can do other stuff like Backblaze. That's another good option too. A lot of these players come and go over the years because unlimited storage isn't really unlimited, and bandwidth fees go up and down and all the rest of it. So you can't ever really truly beat owning the backup targets. Like I said, I own the data, but I also own the outages, so that kind of sucks. Example being, my UK server a few months ago decided it wasn't going to boot anymore. So I had to call up a friend from uni that I hadn't spoken to in about 6 years and say, you live 10 miles from my mother-in-law's house. Would you mind just going and seeing what's going on? Turns out the power supply had died in this box. No wonder, it was like 15-year-old power supply. And then I said I had to overnight a power supply from scan.uk to my mother-in-law's house, and then buy this guy a case of cider to say thank you. And it was nice in a way because I rekindled a friendship, but it's not like a service. There's no SLA, right? Like that box could have been offline for years until I next went to England, and who knows when that's going to be at the moment, you know. So very many answers to a very simple question. I tend to do that a lot on the podcast too. But the thing is about self-hosting is it's full of nuance. Like everybody's problems are different. And all you're doing is selecting a bunch of tools. Remember I talked about the craftsmanship of building a solution? There are trade-offs to every single one. And in my case, the remote hands piece of it was a big negative when the power supply went out. But up until that point, it had been nothing but positive. So it's like now I'm aware of that trade-off because I've lived that experience. You know, so go forth and self-host and lose some data from time to time.
The extra warranty you think is worth it now, right?
Oh, you're talking about the Micro Center trip. Yeah, so I don't know if you care too much, but I just built a new server around a Threadripper Pro, and I went to Micro Center for the first time ever. What a shop. I am so glad. So the nearest one to me in Raleigh is in Charlotte, which is about 3 hours away. It's probably good, because otherwise I would probably be homeless, because that store is they've got 3D print. You've all been to a Micro Center, right? Yeah, it's like Mecca for me now. But yeah, the sales associate, I was buying a Threadripper Pro CPU for like $900 or something, and then a motherboard for $1,000, and he was like, "Do you want to spend an extra $300 on the service plan?" And I was like, "Nah." And then he talked me through the benefits of it, and I was like, well, if it breaks in 2.5 years' time, you can bring it back and we'll give you store credit for the exact amount you paid today. And I'm like, it'd be a shame if that happened, wouldn't it? I'm not going to commit fraud, don't worry, but it's just I could see some people would. It's just nice to have that peace of mind. Part 2 is coming out next week, by the way. The motherboard didn't fit in the case. So there will be a part 3. Yeah. You could go and buy a banana 2x4 from Home Depot instead, yeah. Yes, sir.
What was the name of that service that you send a hard drive to a pre?
ZFS.rent. I have no affiliation, but I have spoken to the guy a couple of times. He seems pretty nice. Their pricing is just really quite unbelievable. $10 a month per hard drive. All that you have to do is buy the physical disk. Yeah, it's pretty sweet, yeah. Go compare that to rsync.net or something, and you'll see why it's such an unbelievable price. Any more?
Does ZFS.rent work with ButterFS subvolumes?
What do you think? I don't know, actually. You'd have to email him. I think you get a shell to a remote session. I'm not sure. I know, for example, that rsync limit very specific subsets of commands you can run against the data sets. I'm not sure how secure ZFS.rent is in that regard, so maybe. But are you running ButterFS in pseudoprod?
Yes, on my
And you still have hair, too. I mean, that's... So when are you switching to Bcachefs then? Yeah. Yeah, I don't know. There's something about Btrfs. I mean, it's part of the kernel. I mean, that's a big plus over ZFS, of course. But I don't know. I just why can't I trust it? Like I just can't seem to. Maybe. Okay. I do mirrors with ZFS, at the minute, so should be fine, huh? I suppose Facebook have spent a lot of money on Btrfs since a decade ago, but file systems have exactly one chance to screw me over, and Btrfs did, so maybe that's why I don't trust it. Any more? Pretty much bang on time, I think, so thank you.
Mic check, 1, 2.
It goes on your ears, so turn around. Turn around. Like that.
Testing.
Mic check, 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 check.
Thank you all for coming. You know, it's amazing to see so many faces here in this room. I'm absolutely delighted to be here. Today, we are here demonstrating Bazite. That is a Linux gaming image designed to bring the best of Linux gaming to all of your devices. I'll let Noel introduce me.
Yes, so this is Kyle Gospo. He has been modding source games since a wee lad. He's a community Linux engineer at Microsoft. He is addicted to Deadlocker. Is that me?
That's you.
No, that's me. What are you all about? Oh yeah, ask him for some swag, and you know, he's the founder of Bazite. He's Mr. Bazite, as I like to call him.
Good luck finding me, though. I look like 200 penguins. I blend right in. All right, and my partner here is Noel Miller. He is not a dog. I know it looks otherwise. Core contributor at Bazite and Universal Blue. Our installer would not exist without this man, so say thanks. Technical account manager at Red Hat. I appreciate that. He enjoys spending time with his family and pets, and he is the one who is addicted to Deadlock. I will survive the accusation. Thank you. So, why are we here, right? We're here to build the future of Linux gaming together, and I feel that now is our chance, okay? Microsoft is dropping support for Windows 10 here very shortly, and if you check Steam's own charts for what operating systems are in use on Steam, you will find Windows 10 makes a huge portion of that. Those users will have to go somewhere. They can't stay on 10. Linux has also moved into new markets. We have gaming tablets. We have gaming handhelds from and Linux has a place there. So, what is all this about, right? Bazite at its core is an example of a community that used to mod video games coming together to mod entire operating systems. The same people that used to make, you know, your favorite Half-Life mod, your favorite Titanfall 2 mod can now take custom images, thanks to Universal Blue, if you saw that previous talk, and turn them into experiences or appliances, making things like these handhelds not only functional, but highly optimized and highly customizable. Bazite, by design, is ready to use, meaning a new user who's never touched Linux before, you know, Windows user, can go right on ahead and install it and be up and running within 20 minutes. Steam comes pre-installed, all the drivers they need are pre-installed. It is a no configuration, no package installation experience. It's also convergent, right? I mentioned all this different hardware. The beauty of it is you have the same UI on every piece of hardware. I have KDE or GNOME on my tablet, KDE or GNOME on my handheld. I have it on my projector in my living room, and I have it on my desktop. It's the same everywhere. It's also bulletproof. So what I mean by bulletproof is it's atomic. Every update moves you to a brand new functioning image that is tested and built in GitHub. That guarantees you a level of stability that is hard to get anywhere else. And if there is a problem, you can simply roll back. You can do so from the boot screen or from the command line, right? GitHub, in their container registry, stores images for, 200 days?
Yeah, it's 90 days, I believe, but
we have it
them
maxed out.
in 200 days, yeah.
You can pick any date in that range and just move to that image. So if I feel that my NVIDIA driver at home, right, ran better a month ago, no problem. I can use the image from a month ago. There's nothing stopping me from pinning it and staying on it. It also ships with Steam Gaming Mode. So in addition to them all running the same desktop environment, they can all run the same beautiful Steam UI you know and love. And that means you can turn all of this different hardware into gaming consoles. I think that's huge, right? These are true appliances that you can just hand people and not have to maintain. We rely on a tool called Handheld Daemon. That's something that we developed in-house. Basically, that's our handheld device controller. It's written in Python, meaning all of it's done in user space where we can iterate rapidly. And it provides TDP control on obscure hardware like handhelds. It provides all of the extra button support on all these different input methods they use. And it also gives us the ability to rapidly bring on new hardware. We'll talk about that more later. So, channeling talking heads, how did I get here? Bazzite has very humble origins. I mean, what you see here is everything I could piece together from 2 years ago. This is the Titanfall 2 North Star Discord. We have the very earliest inkling of an idea here in the top left. I wanted to see if I could throw SteamOS in DistroBox. I did it. It sucked. I threw it away. 2 months later, though, I had this idea. I saw, where'd he go? George Castro's videos. He was doing OCI containers of Fedora Silverblue.
We see you, George.
Can't hide back there for long. And I felt, okay, you know, maybe I can take this concept and I can apply it to SteamOS. I can take all the SteamOS packages, port them to Fedora, throw them in an OCI container, and have it. And then about a few months later, I know they say don't meet your heroes. I did. Turns out he's really cool. He brought me into the Universal Blue Discord, and Bazzite became an official Universal Blue project. From there, you know, because I never intended this to blow up into what it did, right? It was the same concept as putting it in DistroBox. I just wanted a weekend project. But being in Universal Blue meant eyes, and people came, they contributed, and they showed me I really had something here. And that's how this project started, right? It's an accident that blew up into one of the largest new projects in Linux right now. That's amazing. If we could, please, can we get a round of applause for George? It's actually his birthday.
Woo!
Happy birthday, George. Woo! So, milestones, right? We're still a pretty new project. There's only about 2 years of history here. You can see, you know, between joining Universal Blue and, or Universal Blue being born in our first commit, it's only a short jump. We joined Universal Blue not much long after that, and we had a 1.0 release a few months after that. You know, all these extra eyes really do lead to better development. From there, we were the first distro to support the ROG Ally X. I'm very proud of that. A lot of kernel modifications from all over our community went into making that happen. More recently, we had the year of the Linux gaming desktop. So for those that didn't see it, Framework did a 2.0 launch event for their hardware. They actually showcased Bazzite and Playtron on their Framework desktop. That's a major announcement from a hardware manufacturer. I don't think that's happened recently outside of Valve with their own hardware. And of course today, 5,000 and I think that number's out of date, 5,500 commits later, we're here at SCaLE. Thank you, thank you. So, bring you back to our previous talk. We have one model for the Linux desktop at Universal Blue, or the only thing immutable about Universal Blue is our will. I know that's a lot of buzzwords here, but the main thing is we try to shy away from the word immutable. Nothing about this is immutable. It's image-based. It's infinitely modifiable. And it's simply bringing standards that have existed in Linux servers or Linux enterprise to the desktop. This is cloud-native standard. It's as Linux as it gets. So, I have to warn you, right? If you came here to see an hour of Bazzite, I must disappoint you. I'm far more interested in your projects, or the ones you haven't started yet, than you are in mine. We're going to cover all the lessons I learned over the last 2 years here so that you can build the next Bazzite, and I can sit in the audience and watch you up here. So, my first bit of advice, right? Be cloud native. What does that mean, right? As I already mentioned, it means being industry standard. It's everything under the sun in Linux is already cloud native. We're just bringing it to the desktop and to all these fun devices where it belongs. It means being approachable to new contributors. So part of cloud native is having a properly functioning code of conduct and having an open, welcoming community. A lot of our top contributors are people who did not feel welcome at other projects, and we've done very, very well to make sure they're happy here. Also, another important note is the majority of Bazite's contributors have never contributed to Linux before, right? Like, we're appealing to gamers, we're appealing to normal people, and we get a lot of them coming in to make changes, which drives growth of everything we're doing here. That's huge. Promised you I'm not. All right, so last thing is, community focused, and it's a lot of the same thing, right? Bring in new people, make sure they're happy, make sure they're welcome, and keep things flowing. To power that, we use BootC. BootC is this wonderful product that originated at Red Hat, but is now part of the Cloud Native Computing Foundation, so it's as open as it comes. BootC for us means less configuration drift, right? Every single image that we update you to is a known good image. You just chunk along to the next well-tested thing. It also means upgrade reliability for that very same mechanism. It puts us in the industry standard because this is used all over the place. And it provides us infinite customization. There'll be a demo of that later. It's not a live demo because we've learned our lesson, but you'll see it. And lastly, the cool thing is it's just a normal container. This is the same Docker container file that many of you are already used to. The only difference is we're adding a kernel. Just add water. Why do we go black? Seems like Figma's having a bad day. Maybe the Wi-Fi in this room died. Let's see. Gone in airplane mode. We'll be fine. There it is. So next piece of advice, right? Give your users what they want. FlatHub it's a hot topic in some circles. I don't think it should be. This is one of the best things to happen to Linux in the last decade. It provides a stable, secure, and functioning repository for every application you could possibly ask for. It also, more importantly, provides economical stability to developers. FlatHub is about to launch a payment program so that OSS developers can actually get money for their applications directly through FlatHub. So that means all the, yeah! Woo! I can finally pay for GIMP. It's also developer-focused and developer-run, right? If I'm an application packager, I am fully in control of my package, and that's on every distro FlatHub is a part of. Every other solution puts other people in charge of packaging, and mistakes can happen along the way. With FlatHub, I know it's my work that's going to end up on the actual user's experience. Lastly, it's a better experience for your users, right? One cool thing about FlatHub over most other things, it's a one-click button install. Not even Windows has that in most cases these days. It also gives you a layer of sandboxing, and more importantly, it gives you cleanliness in your config files, right? Everything in FlatHub is sort of containerized into a .var directory. If I delete a package, I'm deleting all of the cruft that came along with it. It's huge.
Please use FlatHub.
Right. In short, you're figuring out the operating system by using this model. Let the pros, the actual developers themselves, figure out the applications. I don't want to have to sit here and fight with packaging. I just want to play Halo, right? That's what this is all about. Woo, woo, woo! Thank you. All right, next piece of advice. Use existing infrastructure. So at Universal Blue and on Bazite, we use GitHub Actions, Fedora Copper, Cloudflare R2, it's where our ISOs are hosted, and we use repositories from all over the place. We use them from Terra, they're the folks in front here. Use them from Negativo, RPM Fusion, anywhere we can to get high-quality, well-tested packages. Serving 30,000 weekly users, Universal Blue spends less than $100 a month. And it's all thanks to that existing infrastructure. Next one, right? Pragmatism is better for your audience than idealism. All right, so Kyle, you nerd, what does that mean? Basically, don't harm your project to push your ideals, okay? Steam might be a closed source game store. You might want something open. Every gamer on Earth is already using Steam, though. So installing it means you have the highest chance of getting users. Discord, right? Like, I could use Element, and I love Element, it's nice, but there's 150 million active monthly users. I don't think those should be relegated to an unofficial Discord somewhere. Support them. There's nothing stopping you from doing it. It's a free service. And lastly, working hardware, right? This isn't a problem everywhere, but in a gaming distro, right? 70% of the computer market is using Team Green. If you're not shipping Team Green drivers, you're losing 70% of your audience. They might be a pain to deal with, they might be closed source, but supporting them and getting those users now means you might have better drivers in the future, or at least have enough users to get better drivers or direct hardware in the future. Next cool thing, right? If you are cloud native, you're industry standard, so you get industry attention. It's massive. Cloud native brings investment to open source, right? It's one of the biggest paying things in Linux. Cloud native developers are also excellent contributors, right? These are the sort of people you want to come join you and work on your project. And if you're giving them tools they already know and understand, they're just going to want to show up that much more. Last cool thing, skills learned working on Bazzite or working on Universal Blue are applicable to real Linux jobs that pay real money. A huge number of our contributors... At you, it's your doing. A huge number of our contributors are now actually in the industry, thanks to stuff they learned working on this. So all of these different company logos you see here on screen are actual company people that we have working on Universal Blue. These are all our alumni, all across the industry. It is, yeah. Hey, it wouldn't be a gaming distro without it. Next piece of advice, right? Sit on the shoulders of giants. Open source is entirely built on the people that came before. And you should be proud of the work that you pull from other people. Hard work went into making it. Hard work will continue to go into making it. There's no theft here. It's just open embracing of open standards. So, in that light, right, Bazzite very proudly stands on the shoulders of the Fedora project for our wonderful base images, on SteamOS for the entire GameScope model that we use for the console sessions, on Chimera OS for the actual GameScope package we use, on Nobara for being the trailblazer in Fedora gaming. Seriously, so many of our tweaks come from there. On Bootc for being the backbone of the project, and on Universal Blue for our base images and really the entire model itself, which is an extension of the Cloud Native Computing Foundation and all of the wonderful work that Red Hat has put into making this happen. So, that is the full and complete model. Noel, do you have any comments you want to make on that before we move on?
No, man. Just slay. Keep going.
All right. So, let's prove the model, right? Why should you do all this? Why listen to me and be cloud native? One big benefit we have from all of this is our device support. We get sometimes negative day device support thanks to this. Part of it goes into HHD. Being implemented in user space means that we can rapidly iterate on what HHD supports. The other half of it is Bootc and our GitHub actions. So one real world example, we had a user with no existing Linux knowledge. They had never built a Linux kernel, they had never installed Linux, but they have a Legion Go S that just broke street date by a week. And they would really like Bazzite on it. It would be really cool. So they reach out to us over Discord, please support it. And they ask us if, hey, can you support it? Well, we don't have hardware. But we can ship them a custom image. It takes less than 1 hour to build an image and ship it straight to them. One command for them to switch to that custom image. So we do. We give them something that we think might work. And they go back and forth with us on Discord about it. We ship them custom HHD versions because it's just user space Python. One command can move them on to the next testing version in a little Python and virtual environment. And we were able to get Legion Go S support before it broke street day, before it released.
Please clap. That's amazing.
Thank you. So, quick shout out to all these companies here, from Framework, Lenovo, Ampere, Asus, Retroid, MSI, and GPD. They have all sent us hardware as well. I think that's massive, right? That's kind of rare for Linux community projects, and it's cool that all these manufacturers are genuinely interested in supporting Linux gaming. So they deserve an extra thanks too.
Absolutely.
The next thing we've gotten is explosive growth. So appealing to mainstream gamers means you get mainstream attention. As Universal Blue calls it, we try to appeal to the 96%, because the 4% already using Linux are not your growth target. They have been there for the last 30 years. They're not going to change. The chart here shows our weekly user count jumping more than 4 times up to its current of 26,000 users.
Woo!
Thank you. Thank you. Another cool fact is we have 11 million polls out of our GitHub container registry across just the Bazite images. Poll is anything that does an update or a brand new install, so even that number is wildly up there. The weekly user count is based on updates only. That's Fedora Count Me, and it's anonymized, importantly. I should just mention that. These are our raw Cloudflare numbers. You can tell it's a screenshot because I left in that useless % cache number, but 265,000 unique visitors and 475 terabytes of ISO downloads in just the last 30 days.
Thank you, Cloudflare.
Yeah, thank you very much, Cloudflare.
Is it?
I'm going to not answer that for fear of my safety. The other cool thing that happened, I mentioned this a little bit earlier, is we got attention from Framework. So for their 2.0 launch event, they did a shout out to 2 of the major players in Linux gaming right now for their Framework desktop. This was actually in their keynote. You can go look at the recorded copy, but I think it's amazing to see an open and supportive company like Framework actually interested in this. That's huge.
Finally, the year of the Linux desktop.
It's almost here.
I've been waiting.
This is the year. Don't quote me, though. This is the booth that they gave us as well, just to show. The Framework desktop unit they gave us had pins for both Fedora and Bazite, so there's more of that open, love there, right? Bazite doesn't compete with Fedora. It's an extension upon it. It's also given us mainstream attention, right? There's lots of different Linux magazines out there, but appealing to gamers or a more general audience means you get the likes of Ars Technica or Forbes or The Verge talking about you. We've never had an article on Phoronix. We only recently got on to DistroWatch. I think that was last week. But, that's appealing to the 4%, right? Appealing to mainstream is your audience driver. We've gotten a YouTube presence out of all of this as well, right? Gaming's very popular. So we have a Digital Foundry video. I'm like so proud about that. I'm to the moon. I never thought that I'd ever end up on that channel. They're the best. And then also, we've had lots of very fun random videos, right? You have Apple's Stupid Trash Cans, one of my favorite videos on Bazite, 500,000 views. Same with ETA Prime. He does a video every other day about this project, I feel like, but they push serious numbers because people want to play their games. They don't want to have to deal with, the complicated PC experience on a handheld. It's also given us a lot of community attention. These are just a small splattering of people that we've enjoyed the comments of, but they're out there, they're everywhere. You hop on Reddit, and if it's not someone talking about Bazite, it's probably someone accusing us of guerrilla marketing. Here's some of the battle stations that users have shared in our Discord. The one on the bottom right is this very cool custom HTPC. Bottom center is a Steam Deck being used as a traditional desktop PC, but it's the top left that I am most excited about. This is one of our contributors' 10-year-old daughter's computers. That is a little girl who is going to grow up playing on Linux.
Woo!
I don't think that's ever happened before. That's massive. So, how can you join in, right? I would like you to build your own. You don't have to use the images I make. You can customize them infinitely. That's part of that cloud-native philosophy I shared earlier. Our images all start with Fedora. Every build pulls whatever the latest images from Fedora are. They get brought into Universal Blue and turned into a base image. From there, they're consumed by Bazite and turned into a Bazite image. And now you, as the image maker, can consume Bazite and make any change that you would like to it.
It's important to note, too, you can use any part of that pipeline. So if you want to make a specific experience that you have in mind that even isn't gaming or whatever it is that you want, you can do that. And that, I think, is what is so amazing about this model.
Yes, so feel free to pull from any part of the chain, of course. Feel free to fork us. You don't have to build from Bazite. You can simply take over my container file and make your own changes too. Any part of this pipeline is customizable in any way that you feel. The example that we are going to go with today is using what's called the Universal Blue image template. This lets you take another image, consume it, and modify it. So we're going to modify Bazite today. I'm not doing a live demo because the Wi-Fi's been so spotty. Instead, you got to deal with screenshots, but I'll walk you through it.
He learned his lesson from us.
I'm going to learn someone else's lesson. That's part of the talk. So here's our image template GitHub. I will go ahead and fork it. Very simple. It's all done through GitHub. Once I have my fork, which I have lovingly named Bazite SCaLE 22x Demo, I can make my changes. So we'll cut to that. Here's my Sublime merge window. And you can see here what I have done is change the target to Bazite Deck Stable, which is our KDE image for handheld hardware. And I've made a single line change. I do DNF5 install Plasma Mobile. So that is now a Plasma Mobile Bazite image, one line change. From there, I commit it. And because it's in GitHub and built with GitHub Actions, it automatically builds that entire image. So here's a small screen cap of that build process showing in highlighted blue there the Plasma Mobile package being added. And so you can check it out for yourself. Here are two QR codes. Left one will take you to the uBlue image template. The right one will take you to the repo I just showed you. So you can go ahead, pull that image down, play with it. It is live on my GitHub and will stay there in perpetuity. I've also left the action enabled so it will auto-update. So in a month from now, you can go ahead and look at how it broke because we broke something upstream.
That would never happen.
Now, through that same process, we've had some very interesting community attention. I just want to shout out these two projects. Over the last 2 years, and maybe this is a lesson to learn, we have offered other desktop environments. Right now, we only support KDE and GNOME. But I've offered Budgie, and I've offered Cosmic as future targets. I'm one man. I'm slow. I don't support them yet. Cosmic in particular, I'm waiting for stable. But the community, ever hungry, they will make it themselves if you let them. So that same process I just showed you has led to these two. On the left, you have, we're going to call it Phosphor. That is a Hyperland Bazite image. I didn't even know it existed until last week, but there it is. On the right is Stellarite. That is a Cosmic image. It's built from official System 76 sources with the alpha version of the Cosmic desktop environment on top of everything that we've built. I think it's amazing that it's even on offer, and this is just a small splattering of community projects. There's all sorts of custom Bazite images out there that I've never seen. So, if you don't want to build a custom image, you'd rather help us out, you can contribute. How are we on time, by the way? We're very good.
29, yep, we're good.
So, technical or not, open pull requests, right? That can be anything. You could help us with our docs, which we very much appreciate. The guy that wrote our docs did such a good job, they got burnt out and had to stop. They're excellent.
Please help them.
Or if you know code, pop in, change the container file. Let us know if something could be better. We're always open to pull requests. We're not going to be mean to you if we don't accept it. We're going to say thanks regardless. You can also work upstream. So Bazite pulls from all of these projects here on the right. a contribution to any one of them benefits us. We need help with our first install tool. The one we use right now is called Yafty. That one has unfortunately lost its maintainer. It plays a small part in what Bazzite ultimately is, but an improved version from someone who's interested in doing that UI work would be massive to us. You can help us support more hardware. If you know anything about Python or you're into kernel stuff at all and you have hardware we don't, reach out, talk to us. We would love to see what you have to offer. Any help at all with eliminating installation friction would go a long way too. Right now we rely on Anaconda. It is less than ideal, let's say.
They tell me I wrangle Anaconda, and I think a lot of times it chokes me out.
Yeah, think this guy again, right? Anaconda, as bad as it is, doesn't work at all without his work. Thank you, Noel. So another thing I hear often about open source projects is them having small teams, right? Cloud Native goes a long way in reducing that because a lot of the work that goes into making something like Bazzite, we don't have to do. We get support from Fedora because they're the ones doing all the security patches on their base images, and we get support from all over the industry. We get support from Universal Blue. So our team, it's going to take up multiple slides, is made up of all of these fine people. I want to shout out just a couple of them. You have Antheus. He is the lead maintainer of HHD, and he is the mad scientist responsible for most of the handhelds that we support. You have Jan, who was our original kernel maintainer. Again, numerous Linux gaming improvements came out of them. Quick shout out to Brian Kettleson. He was a major part of our original model and all the image maintenance that's gone into it. And Sean there made all the wonderful videos you see when you start Bazzite up for the first time. Wolfie did all of the videos in our documentation that have helped people dual boot Bazzite for the last year and a half. They deserve a huge thanks for that. George, our resident dinosaur guy, we would know nothing about dinosaurs without him, so thank you. Woo! Yep. Pat Connors there is the one who did our documentation. Like I said, they got burnout, but they deserve all the praise. Our documentation's wonderful. And Valerie there is the one responsible for our social media and all the lovely posts that I'm sure you don't want to look at. That's just the core team, of course, too, right? We have over 100 contributors on GitHub, and that number is only going up. The more the merrier. So, in summary, then we get to questions. Cloud Native reduces your development friction, it follows modern standards, and it allows you to focus on only what matters. FlatHub as an application source improves the experience for your end users, and your application developers will thank you. They are finally in control of their packages and not wondering why things are broken downstream. Utilizing existing infrastructure will save you both time and money. As I mentioned earlier, it's $100 a month to run all of this. It's very cheap. Supporting applications and hardware that your users are already using will improve your growth targets and lead to further adoption. That means have an official Discord. It's very handy. Support NVIDIA. Yeah, it might be a pain, but they're 70% of your audience. You have to. And lastly,
got a few gray hairs from working on NVIDIA, so.
Programming's not stressful.
No, not at all.
Lastly, wear your influences and your upstream code sources with pride. Just always remember, we're building on things other people have built, and none of us would be here without them. I want to thank you all for coming to the talk. Thank you very much. Anyway, I hope you're having a great SCaLE. We'll be back next year with probably way more cool stuff to show off and more hardware. We're going to have plenty of time for questions too, so I'll take every question you have, hopefully. And lastly, that QR code there will take you to our website, so feel free to take it out and take a look and check it out.
All right.
I saw that you had support for ARM devices
Yes.
as a goal. Can you speak more to that? Just like any of the challenges that you're foresee going forward with that? Or
So if you go to the show floor right now and go to the ARM booth, you'll find an Ampere workstation with a copy of Bluefin running on it. That's a sister project to this. We're doing something similar for Apple hardware as a first target. So if you go into Bazite's pull request section, there is a Asahi-based image sitting there to get that fully up and running. I think actually Meta's booth has something very similar, like live, that you can check out. But the main concept is using FEX to emulate x86 on ARM and running everything through that. Early tests are fairly positive. You know, ARM's kind of a complicated landscape, and we're going to slowly support more of it, but Apple's a good first target because there's a lot of people staring at it right now.
Yeah, that's awesome. Thank you.
Thank you.
I saw you had the post or the section about looking at an alternative to Anaconda. I'm so sorry. I'm with the OpenSUSE people, and we're actually, it looks like the community is going to be killing Yast, our longtime installer, for the past 30 plus years.
Yes.
And there's already a project to replace it, and it's already being used. It might be useful for you guys as well.
I would be very interested to hear from you, for sure.
Would you like the name?
Yes.
Okay, it's on my radar. AGAMA. Agama.
Agama, okay.
Okay, cool.
Fantastic, yeah. If it supports boot C, I mean, definitely. Or if it, could be made to.
So I started using Bazite about a year ago, right?
Yes.
And one of the problems that I ran into was that it had SE Linux enabled on it. Like,
Yes.
for the most part, it's pretty smooth, right? But SE Linux doesn't play well with certain things, and it can just turn into a total nightmare. So why SE Linux in the first place?
Well, it's part of a standard of security, right? Fedora ships it to maintain
usually
a
with
secure...
enterprise servers for the most part, yeah. But I mean, because most people want to use Bazite as a desktop, right? Like as a general desktop. So
Dinosaur Man might have a word of wisdom.
So not anymore, right? Because I went through all the steps to basically figure out what was going on. But when it came to actually working with stuff with networking in general, Jellyfin was one of the first things that I installed, right? Like back last year. I originally did it just as like an actual like regular RPM install, right? No, yeah. I ended up learning. Yes. Eventually I learned, right? Yeah.
Yeah.
A lot of this is transformative, right? Like if you came from a traditional Linux, right, apt-get install nginx. I'm cloud native. It's Docker pull nginx, right? So for a lot of people, it's like you're not installing packages, all the server stuff. It's going to be from Linux server. It's going to be from cgr.dev. It's going to be, so my goal is to take the Linux desktop, kicking, dragging, and screaming through its cloud native journey, like how we did with Kubernetes. We're doing Kubernetes again. Oh no, a lot of YAML, but you know what? It works.
Thank you, George. So, short version, right? SE Linux means you have a secure desktop. I think it's important on desktops. It might be a little less useful on handhelds, but if there is an SE Linux related issue affecting gaming, it's either something that we're open to pull requests for just to make a rule to make sure it doesn't break it, or something that we would go out of our way to fix ourselves. In the past, Half-Life 2 had a bug that would cause it to not play audio with SE Linux enabled. And since the start, we've shipped a rule for SE Linux to resolve that problem.
It's easier to make Red Hat fix it. You give me numbers, we'll make Red Hat fix it.
Hey, that's part of it too, right? Having count me turned on by default and having that magic 30,000 number means when some game developer says, hey, should I turn on Linux support for our anti-cheat, they have a real potential customer base number to go look at to make that economic decision.
So this is kind of like a random question, but I have a Steam Deck, and like the updates are like crazy long. Would Bazite like be able to like help those updates go faster, because I don't even think it's like normal how.
So our updates can take a while, yes. The one cool thing is we have diffed updates. So as often as we update, every update is just the parts that changed and not the entire image. So thanks to that tech, you might have more frequent updates of a smaller size. SteamOS tends to be whole images of the entire system level of the disk that snap along to the next good release.
Also, just to kind of follow up on that question about SE Linux.
Yeah.
We both have Steam Decks, and one of the things I kind of found weird was that they don't have full disk encryption on a mobile device.
We have full disk.
You do? Okay.
Yes.
So I was wondering, like, if they, that's definitely a bonus, and I'm going to be swapping the Bazite.
Yeah, SE Linux is fully supported, full description is there, and Secure Boot is fully supported.
Woo!
Okay, I run Fedora KDE on my laptop, my framework.
Yeah.
So what's the path of least resistance to run this in parallel, to dual boot it? Can you say more?
Unfortunately, dual booting with Fedora would not be possible. It's only because both projects use the name Fedora as their EFI path, so they would directly conflict with each other. If you were running the atomic version of Fedora, so if you're on Fedora Kinoite, then you could switch over to Bazite in a single console command to give it a try and switch back if you didn't like it in, again, one console command. But from traditional mutable Fedora, I'm afraid a reinstall would be the only path. You can use an external drive to boot it, of course, just to give it a try and see if it's something you want. You're welcome.
As a PC gamer, there's a lot of games out there that use external launchers. Things like Rainbow Six Siege uses Ubisoft Connect. Battle.net itself don't have Linux versions, and the ones that do exist either are not supported or can get you flagged by the anti-cheat. Is there any push for Bazite to potentially support the official launcher versions for these third-party, non-Steam related games?
That is a huge yes. Siege, unfortunately, will never be supported. It uses BattleEye, and it is Ubisoft's choice on whether to support it.
They accidentally turned it on for one day.
It was so nice. So good luck, on that one. But as far as launchers, right, a big part of what goes into Bazite is making smart software choices. So we ship Lutris pre-installed in the image alongside Steam. That means in Lutris, I can click the plus button in the top left, I can search for Diablo 4, and it will go ahead and give me an installer that will install battle.net, put it in my library, and add it to Steam so I can start using it in game mode immediately.
Okay, so you probably get this question a lot. If I was to build my own PC, what would be the most compatible hardware that you would say that would be most compatible with Bazite, but also the most wide-ranging playable of games? Would it be? I know specifically that's Team Red or Team Green, but
I can give you a generic answer.
Okay,
but
awesome.
I'll go as specific as possible, right?
All right.
Avoid Team Green if only if you want a stable image, right? We do the best we can to support them, but their drivers are what they are. We can only do as best as they do. So get as new of an AMD GPU as you can, whatever you want to afford. Intel or AMD CPU doesn't matter. Motherboard doesn't matter. But if you're going to do wireless internet, try to go for Intel Wi-Fi. The AX210 is bulletproof. Some of the newest AMD motherboards ship with I think it's a Qualcomm chip that we're waiting on support for in the kernel. So some people come to us my Ether doesn't work, my Wi-Fi doesn't work.
What about the E210, the new Intel one?
That's fully supported in the kernel too, so you're good there. That's really the main pitfalls. Outside of that, more obscure hardware, of course, like eye trackers or some of the RGB keyboards that don't have support in OpenRGB get a little iffy, but nothing that's going to stop you from playing a game.
And if you're willing to wait, there's the Framework Desktop that is coming later this year that will basically have out-of-the-box support for Bazzite. It will be the simplest on-ramp possible because of all of the work that we do and how we work with Framework.
I can't talk about that one much, but what I did see at their launch event was very, very cool. And you know, as things improve, right, we'll get more attention from the industry. So one of the major wins that we had was Marvel Rivals. In one of their most recent patch notes, Bazzite is actually listed as one of the bugs that they fixed as a target. It was low-resolution HUDs on high-performance computers running Bazzite. I believe their issue was they thought everyone on Linux was a Steam Deck and picked an 800p HUD no matter what your display was. So they fixed it, right? They paid attention and actually put it in their notes. That's what higher numbers can actually drive and get people to be interested in.
I'm big about math and numbers, right? Marvel, a Marvel property, mentioned us in their release notes. What does it take to get a company like, well, it's NetEase, a Marvel licensed thing to pay attention to Linux users?
$100
At least
a month,
30,000
nerds?
of us. Did we get lucky? Absolutely. We make our own luck. We make our own luck. If we make numbers go up and to the right, we can get what we want. That's all we're trying to do. Sorry, I'm over talking.
No, you're good. Anybody have any other questions? Yell at me if I don't see ya.
One more.
All right.
Do you have Bazzite that works with iPads?
Unfortunately not. I don't know if that'll ever be a supported target given that hardware's a little locked down, but ARM MacBooks, certainly an older x86
Or
MacBook.
any like touchscreen devices?
Oh yeah, so
moonlight to an iPad,
you could have Bazzite on another piece of hardware like a home theater PC, and then install something called Moonlight on your iPad, which will stream it across your network to your iPad to play anywhere you want in your house.
I do it with my phone all the time. It's great.
It's very reliable.
Genuinely great.
Cool. Any other questions, anybody?
Yes, absolutely.
Thanks for coming.
Woo! Let's have a wonderful rest of the convention, and game night starts now, so.
Yeah, have a great game night.
Go have fun. If y'all want stickers, we got stickers, and none of them we're taking home, I hope. We got stickers. Yep, these are case badges here. Whoop. Yeah, Miniswarm. I use a Miniswarm PC in my living room, so yes.
That's my solution.
Yep.
Yeah, I'll just put it on that.
Yep.
Thanks.
Yep.
Let me have one of the stickers.
Yeah, absolutely. Yeah. Where did Kyle go? Where's all your stickers?
Testing, testing. Perfect. Okay.
Good evening, everybody. It's the last presentation today. We're at Port Forwarding Risk when Self-Hosting. Please welcome Sam Hanna.
Thank you, thank you. Thank you for being here this late. I'm surprised there's still people here. But yeah, welcome. This is Port Forwarding Risks when Self-Hosting. Just want to get a hands of is anybody here self-hosting or interested in it? Okay, cool. All right. I got a right crowd here. So yeah, just before we get started, I just want to give you a little bit about myself. My name is Sam Hanna. I'm pretty much just, I've been using Linux for over 15 years, and pretty much most of the stuff I've learned over the years have been self-taught. So basically, and also got into self-hosting myself for the past roughly around 10 years. Starting, with a media server, and then slowly got into other stuff like Nextcloud and other great applications that are available. This is my second appearance as a speaker. I feel like I'm still a newbie, but I'm glad I was able to have this experience. I like to advocate open source and self-hosting, and my goal really is just to, with the knowledge I've had over the years, I would like to kind of spread it over, and hopefully others can be inspired like I was over the years that I've listened to and watched over on, to learn what I've done so far. So what we're going to be talking about this is a list of basically what we're going to be going through. Basically, we're going to talk about what is port forwarding and why we port forward, the risks of it, most importantly, and ways we can secure ourselves. I have a little demonstration of the last part of trying to access a device without port forwarding. I'm going to try to see if it works with the Wi-Fi here. I heard it was spotty, so it's working now, but I'm hoping it will continue working when I'm get to that part. But yeah, we're just going to do a little experience with that, talk about how to access devices without port forwarding, just so that way we can, keep ourselves secure, that way we're keeping our privacy and all our data safe. So we're going to talk about what is port forwarding. So basically, port forwarding is a way to open, so basically a router, and most routers have this ability, and it really depends on what kind of router you have. Some ISP routers may have this ability and some don't. If you have your own router, there's a good chance you'll have this capability. And you also want to make sure that your ISP allows you to port forward. So even though you have your own router, if you try to port forward, there's a chance that you may not be able to. There's a few examples how I'll give you an example later on, but so basically, routers have ports that make it all available for communication to go across from the internet inside your network. So there are many ports. There's many ports that you basically can use. But the most common ones are port 80, port 443, port 22, which is for SSH. Port 80 and 443 are common, or really common when you're trying to do like a web server or anything that's over the HTTP network, or if you're using HTTPS. But there's also port 25 and 53, which is for your DNS, if you have a DNS server. There's a lot of ports. There's 65,535, but not all of them are usable. At least what I mean is that there's some that are pre-assigned, like I just mentioned earlier. And usually the first 1023 ports are assigned already. And then the rest of them, you can use them however you want. Usually you can assign an application or a service, an IP address outside that area. So that way you can basically have multiple applications running on the same router or service. This allows it, you can have multiple PCs, or you can have the same PC using multiple ports to keep them open if you want to have, like I said, multiple applications. So like I said, most routers have this feature. It depends on what kind you're using and if it's an ISP. I have seen some that don't have it, don't allow it. So like, for instance, I was, in the last part here, it says that like if you're using something like T-Mobile wireless internet or any kind of, wireless internet, like Starlink and anything like that, they usually don't give you that option because it's using a feature called CGNAT, which is carrier grade network address translation. And that's basically, it's only, the ISP is controlling what's coming in and coming out. So you don't really have that much capability of trying to get access to your devices outside of the network unless you're using some kind of third party. Like if you're you'd say like you have cameras you want to get access to, you would use something like Ring or something because you would use a third party service to actually have access to your devices. But I'm going to show you ways you can do this yourself so you don't have to rely on a third-party service or anything proprietary. So just to give you like a little introduction to it, usually port forward is if you do have this available on your router, usually it's in the advanced settings. And if you go to your port forwarding section, you can select the IP address of the device that you want to have to expose to the internet, and you can even select the port that you want to give it. And usually you could select one of the pre-assigned ones that are, if it's like a HTTP or HTTPS, or if you wanted to give it a custom port, like if it's something like you're doing like a Nextcloud server, or any other server that kind of doesn't need a specific port, you can give it a custom IP address. And once you apply it, as long as your ISP allows it with their router, or if you're using your own router, should be able to get access it with using the private IP address, not the public. But you'll be able to get access to it with using the private IP address. So why do we do this? Well, I'm pretty sure I've explained this, but basically, if you want to get access to any of your devices in your network, you'll need to have at least one of the ports open to get access. And majority of the time, you're probably going to be port forwarding port 80 and 443, only because if you're using something like a reverse proxy server, that requires those two ports to be open in order for you to try to set up a domain name. And usually, if you want to set up something like that, it's going to require at least those two ports. But you're welcome to open other ports if you're planning not to use a reverse proxy. But that's basically why we have to port forward. Because by default, routers usually have the ports closed, and that's just for security purposes to prevent any external access from an intruder or anything like that. So basically, once you port forward, start doing that, then you're going to start experiencing, not experiencing, but you're exposing yourself to vulnerabilities. So what are the risks? Well, the main reason and the number one reason that is if you are opening a port without any security measures, all your traffic is clear text. So if you were to basically open a port to some specific service, like let's say a Nextcloud, and let's say you just randomly go to a coffee shop and typed in your private IP address with the port number assigned to that Nextcloud server, all the traffic coming out from your laptop to your server is all clear text. That means anybody who's just using like a packet sniffer is going to be able to see your information. And that includes anything like if you're trying to connect to a remote server, if you're using a password, that's all going to be seen through clear text. And this also allows us to have unauthorized access to devices. And that's the same thing. Anytime someone's going to have see information or packets, they're going to see that you're probably connecting to a device, and they're going to probably find out what that device is and see what information's on there. So this gives them an opportunity to kind of be curious and kind of give them an open opportunity, really. So And this also gives you, more potential for malware. So a lot of times you might say, what are the chances? It could be rare, but, you can never give it any, you don't really want to give it a chance, because something like this can actually affect your entire, not just your server, but probably your entire network, especially if you're trying to do this in your private home. You don't want something that could infect a wide range of, family members' devices. So this is something that we want to also prevent. So brute force attacks are really mainly if someone's trying to remote access into your device. Like especially if you're trying to SSH into a remote server. If somebody doesn't have has a password to, or has the encryption key or the password to attack it, to get connect to it, it's gonna basically they're gonna brute force it. Basically, they're gonna try to break the password code to actually connect to it. It's a very tedious process, but this is something that could happen, and usually could happen to maybe more of a corporation, because this is something that if they really want to get into it, they'll probably try to do it. And anytime when you hear something about a breach, usually a lot of times it could be just someone opened the port to get access to something, forgot to close it, and they found an opportunity. And then this is also, like I mentioned before, it does give the intruders a way to get to your sensitive data. So this is basically a way, if you have something like a Nextcloud server or any kind of server that contains sensitive information, if you're exposing your basically your infrastructure without any security measures, this is something that could get exposed, and a lot of information, especially sensitive information, can get out in the open, and God knows who will have access to that information. So we want to secure ourselves this way, because this is very important. We don't want anybody to have unauthorized access to your devices. So we want to talk about how we can do that. So the one way is, first thing is, you could restrict IP addresses. So for an example, if you wanted to SSH into one of your devices, you could, if you know your IP address of the client that you're trying to connect to, and you're the only one that's connecting to that device, you could configure your server to only accept any communication with that IP address. And now it's not 100%, only because you're still clear text, but you're narrowing down the opportunity, or basically the opportunity for someone to get access to your infrastructure. Now, another thing you want to do is you don't want to open too many ports if you're doing this, but you only want to open essential ports. So this is if you're just doing a web server, you probably are only going to open port 80 and 443. But in this case, if you're going to do something like that, you might as well put in a reverse proxy server. That way, if you do want to add any more devices, you can limit the amount of ports you're opening and use the reverse proxy to kind of mitigate where you want your traffic without having to do it. But this is, again, we're not getting to the part where this is, even though you're using a reverse proxy, it's still, again, we're still open for vulnerability because we're still clear text, but we're on our way to getting to securing our infrastructure. So this is kind of like a little image I found that kind of demonstrates what it's doing. So you have the client sending a request to get access to one of the devices. The reverse proxy tries to detect which server it's trying to reach, and then it kind of directs it to them. So if you have multiple devices, you don't have to have a port open for each device. You can just use a reverse proxy, and that kind of gives you one layer of security. And you kind of want to make sure you're using a firewall. Usually most routers have a firewall built in. One example is like if you really don't want someone trying to detect your network, there's a feature that blocks pings. And usually if an intruder is trying to ping IP addresses, they could try to find that there's activity, and they may want to try to find how to get in. But if you enable this, this can block pings. The only problem with this is that if you're trying to troubleshoot your network from outside and you try to ping it, you're not going to be able to get any access. So yeah, there's some downside to it, but there's still a layer of security that you could use. Now, there's ways you can monitor the traffic that's coming in. There's a software I just found out. I haven't really used it, but I did find out that there's an open source software called Zabbix, and actually they have a panel here. And actually, it monitors your network and can actually see what traffic's coming through. So if there's anything unusual, you can detect it and probably find out if there's any vulnerabilities there. But the main thing what we want to do is we really want to secure our network. And this is really the most important. I mean, the first 4 steps are good, but we want to make sure this is the final part that we really want to do. Even though we're only port forwarding certain, we're limiting the amount of ports that we're opening, and we have a firewall, we still have an open communication. So we really want to set up, or at least have some kind of secure connection using either a VPN or something close to it. And I will kind of give you more examples of that, what I mean by that. It's more a one-to-one communication between the client and you want with your server. So you kind of want a secure connection using a VPN or some kind of secure remote access that kind of gives you security. Now, a good example I left in the end is SCaLE. SCaLE is a really good software, and I'm kind of going to, when I get to that part, I'm going to give an example of that. But basically, SCaLE is basically a software that you can install on your client or on your and on your server. So that way, if you wanted to communicate with that, you can use the SCaLE VPN connection, and you get basically an encrypted connection, and it basically requires no port forwarding if not necessary, really. But you can if you want to, but it doesn't require it. So there's 3 ways to set up a VPN, and I'm not really going to go into detail about this because I can't really give you a demonstration on that since I can't port forward from here. But I'm going to just discuss ways we can set up a VPN. So I found this on my router, but basically some routers may have this. I don't know if all of them do, but mine actually has a way where I can connect a VPN or set up a VPN on the router itself. It's not enabled right now because I don't use it, but if you enable it, it basically it creates a configuration file that you download and you actually add it to your PC, whether it's a Windows, Linux, or a Mac PC, and even it can actually add it to your Android phone. So if you do have an open VPN app, you just import the configuration. So if you did want an access to any of your devices or to your network from a remote connection, you would enable that VPN, and with that configuration, you'll have an encrypted connection to your network. Now, this is pretty good. I don't use it because it's a little, having an importing configurations can get a little tedious, especially if you're having multiple devices trying to connect, and you want to set up a server. Set up a server where you can access anywhere, but it's a great option. I did it for a little bit and it worked great. But this is one option you have. Yeah. So what I mentioned earlier, if you don't have something like that on your router, you can set up a VPN access, and you can use OpenVPN or WireGuard. And by the way, it would require that the client and the server has this set up, so that way the remote connection is established, and that way you get a good encrypted connection there. Now, the one thing I will want to mention is I do use the term VPN, but I just want to say is using something like NordVPN or private internet access does not do the trick. That's designed for a separate purpose. So that's usually designed for a client to, basically the only encrypted connection there is the client to private internet access. So that kind of helps if you're at a coffee shop or something, but that doesn't give you a one-to-one encrypted connection to your server. You could, but that gets pricey, and I don't think you want to go through that, because that requires setting up that on the remote server with like a static IP, and they charge more for that. But that's not something you want to. I don't want to get confused with just saying the VPN. I want to clarify that that's not something you want to use. But you only want to use set up a open VPN or a WireGuard connection, and that will ensure that your both devices that are communicating are encrypted. So I mentioned it before, but if you really, it does require, the second part does require a lot of technical knowledge, because setting up OpenVPN and WireGuard do require command line, knowledge. So another way to do it is you could set up something like TailScale. And TailScale would be setting up a VPN connection, and mostly it's just a one-line command if you're using Linux. It has a Windows installer, but a one-line command line, and once you log into your account from TailScale, you'll have a one-on-one connection there. It gives yourself a mock IP address or IP address that's assigned by TailScale, and you'll use that IP address to access the server. That way you're encrypted, and if someone sees that IP address, if they try to type it in themselves, if they're not access to your account or your network, they won't be able to access it. So it gives you some privacy there. So just to give you a little diagram of what a VPN would do is basically, if you wanted to port forward, well, basically, if you wanted to, you would dial in the private IP address, and the private IP address, I think I messed up here. It's not supposed to be the VPN setup. It's supposed to be port forwarding. Because what you're supposed to be doing is when you type in the IP address and the port number, the router will basically identify which device you're trying to go to. And that being clear, so if you're using 1024, it will know exactly which device you're going to. But you can actually, this is something that, unless you're having multiple devices that will have access, that's pretty, that's okay. But majority of the time, you may just want to have one device that has all your services. So there is a way to access your devices without port forwarding. Now, there's two ways that you can do this. There's TailScale, which is my recommended way, but the other way is actually Cloudflare. Cloudflare has a feature called Cloudflare Tunnel, and this is really basically if you want to access your services with a domain name. And basically with that, it doesn't require any configuration. You just install the Cloudflare, I believe it's called, and you install it on the main remote machine, and you connect it to your Cloudflare account. And then what you do is you just set up a subdomain, and as you set up the subdomain, you pick the port number, which is assigned to the application if you're using Docker or anything. That way, once that happens, it'll create that subdomain, and you can access your services through the subdomain using an encrypted connection that's using Cloudflare. TailScale is another one, and also that another thing you could do, and I'll explain why you would want to do this, you could also create your own tunnel. And this is how I really access my machine right now. And I'll kind of give you an example, or give you a reason why, but I'll give you talk a little bit more later on. So basically, Cloudflare Tunnel, I explained it earlier, but you can access your server through a custom domain, while your server might have a private IP address. The traffic is routed through Cloudflare's network, meaning that the public IP address seen by the outside world will be a Cloudflare IP address, not your server's IP address, essentially. And Cloudflare Tunnel hides your server's IP address by acting as a proxy. So that's one way, and I did this for a bit. I liked it, but there's some things I will mention why I didn't use it, or I don't use it anymore. So it doesn't require reverse proxy. This eliminates that. You don't need a reverse proxy for that anymore because the Cloudflare acts as your reverse proxy. So it handles everything, and it creates that one-to-one connection from your client to the server using the Cloudflare tunnel. So the downside to it is if you're planning to use something like Plex or Jellyfin, Cloudflare's tunnel does not like it. They don't allow streaming. So the bandwidth is limited. You can use it for static websites, or I've tried it on audio. If you're listening to music, it works pretty good. But streaming, they don't like it. You actually, if you read their terms and agreement, they actually say that streaming is not allowed. And if you try to do it, or at least attempt to too many times, they could ban you. So it's great. It's a great feature, but it's not something I use personally, because if you're doing something like that, it's not going to allow it, and it kind of defeats the purpose if you're trying to have somebody access your Plex or Jellyfin server. So I included a link to how to set that up. It's a short video, but it talks about how to set up a Cloudflare tunnel. It's on YouTube, so it's not going to be it's not a video I made, but it clearly tells you how to set it up, and kind of shows you how simple it is, and how Cloudflare handles the connection and setting up the subdomains. SCaLE. So yeah, this is one of the things I'm going to keep mentioning a lot, because this has helped me a lot in my time doing self-hosting, and I'm going to give you another example why this is very important. But because SCaLE is a really interesting technology. I was just at their panel, and I talked to them, and I gave them my appreciation for it, because I think basically setting up something that doesn't require any configuration, it just saves a lot of time, and it does help with reducing the amount of troubleshooting, especially if you lose connection or something and you don't know if it's the VPN that you set up. SCaLE handles everything for you, and I really like it, and it uses WireGuard in the background to handle all the encrypted connections. And I included another video there that shows you how to set it up, and it's just a one line on the command line if you're on Linux, and it's got a Windows installer, so it's a very easy setup. Once it's connected to your account, you'll have an encrypted VPN connection right away, and it works on all devices, iPhone, Android. So so basically, this is what I did so far. So this is my setup, and this is how you create your own tunnel. So basically, what you're doing is you're setting up a VPS. And you can use any VPS. You can use Linode, DigitalOcean. I use Oracle Cloud. What I use is I use the free tier. And what I've done is you use a VPS and set up a reverse proxy. And what you're doing is on the VPS and on the server, on any of these devices, but if you're using only one, that's fine, but you would install SCaLE on the devices that you want access to, and on the VPS. And what you're doing is you're using the reverse proxy to direct it to the SCaLE IP address of the server you want access to. And it depends on what, if you're using multiple devices for certain situations, that's fine. And it works flawlessly. I've been using it for a few months, and it's working great. So basically, this handles, this will replace the Cloudflare tunnel, and it removes that restriction for streaming. So if you wanted to do a Plex server or a Jellyfin server, and you wanted to have someone access to it, you can actually do something like this, and it will use the VPS to send an encrypted connection through SCaLE to the device that handles that service. And this is something that I've been using for quite a few months, and it's been working really great. The only thing I would say is, yeah, I mean, it's a really, I mean, from what I've been trying to do is, sorry. Yeah, I mean, other than that, another link to a video that shows you how to do this. I actually had this is the video that I watched to learn how to do this, because I wanted to find out a way to be able to set up, get access to my servers without having to, and now, I'm sorry, I screwed up here. The VPS, what you're doing with a reverse proxy is you're using a domain name. I should have mentioned that earlier. So with a domain name, you're going to create subdomains to pinpoint with the reverse proxy to which device, or if you're using one device that's handling multiple applications, basically it will handle that traffic. And like I said, it's been a lifesaver for me. You can use other services. Tailscale is one. This is the one I use the most, but there is zero tier. It does the exact same thing. I just use Tailscale because I just like the dashboard. It's a really good dashboard. All right, so let me do something. I was just going to show you, see if it works, but I have, my server is on so I use T-Mobile, and I can't port forward. So if I'm just going to show you an example real quick. And if you tried to do this yourself with the same IP address, you will not be able to get access to it, but it's working great. So this is, you probably are not seeing this perfectly, but this is getting access to my audiobook server, and this is using Tailscale. I'm having an encrypted connection, and not one port is open on my router. So I'm able to get access to my server without having anything to be exposed. And like I said, if you were to type this in on your PC or phone, it won't do anything. You're not really having any access to my Tailscale account, so you won't be able to see this. And this is an IP address that's assigned by Tailscale. And that's why I have that on my previous slide, is so that way if I'm trying to communicate with my server, with this slide here, using a domain name, the Tailscale handles that connection. So that encrypted connection, there's no way for someone to access that encrypted connection without having my Tailscale credentials. So that connects my VPS to the router, and then the router kind of delivers that information to the web server or service that you have on the devices that are available on your network. It ended up being shorter than I thought. I thought I was going to be talking for a lot longer. So that was it. It was just basically wanted to show how, I mean, basically port forwarding there's nothing wrong with it. You can do it. And if you're able to, and if you feel it's a lot more easier, that's fine. Just make sure that you have some kind of security measures that you're using. I mean, I would say use a reverse proxy. Make sure you're using Let's Encrypt to handle the certificates when you're using Cloudflare. I didn't mention this, but if you're using a reverse proxy, and you want something very simple, I use Nginx Proxy Manager. If you don't want to deal with the command line, it handles everything, does all their certificates. You just it's all point to click. I mean, I don't know, maybe I have time. Maybe I'll pull it up, see if there's let's see if there's a image of it. So it's like, basically like this. This is what it looks like. Yeah, so it's basically like this. You click on hosts. It's going to ask you to add a device. It tells you what subdomain, and you tell it what port number, and it creates the Let's Encrypt certificate for you, and as long as it's behind a good router with, it will handle the encryption all for it by itself. And this is, I use Docker to install it, and very simple to use, and you don't have to deal with the command line. I think that's it. Any questions?
So the T-Mobile Internet, the device that you get from them is a router and an access point. It's everything all in one.
Yeah.
Right? Are you putting a separate router after it?
You can. You don't have to. I chose not to. If I was, my situation, I was having issues with the router. I was not getting a good connection, so I decided to go with a separate router. But even with a separate router, I can't port forward. It doesn't give me the extra capability of it because the modem itself does not give you that option. The service provider takes control over that. So there's no way for you to actually do it. I've tried it myself. It doesn't work.
Do you have that white one, the black one?
I have the black one.
Okay.
Yeah, the newer one is the black one. I think there's another one I saw, but I don't have that one. But for either one of them, either one that you have, it doesn't do port forwarding. And then if you look in the settings, it doesn't give you any option. It's very basic. Just gives you the you can see the list of devices that are connected, change the name and the password, but other than that, that's all it gives you. There's no advanced settings in that type of router.
So you mentioned using SCaLE, and from what I gathered through this event is essentially it's end to end, right, encrypted and everything. So it's like from your phone to your server.
Right.
So what's the benefit that you see in terms of using the VPS, since that's still using SCaLE?
So I probably wasn't clarifying. The VPS part is really for using a domain. So you could, which I've done, is you can, if you have like Cloudflare set up, you can assign the IP addresses to the SCaLE IP address. But the problem is you would have to be on the SCaLE network to access your domain at that point. So you can't do it that way. You can have a private domain name that's only accessed if you have a SCaLE account, a SCaLE connection. That's great, but then like for me, that situation that I've created to create your own tunnel, I did that because I wanted to be able to access my stuff anywhere. Because like on my work laptop, I can't install SCaLE, they won't allow me to. And if I want to get access to my files, or if I have something I want to get connected to my, if I wanted to get connected to work, I can do it with the Cloudflare, the tunnel that I created my own. So I have a domain name that I've created with pointing, let's do this. So I'm pointing basically the only person that's gonna, when they connect to my domain name, let's say if they found out what my domain name is, they're only gonna see the IP address of the VPS. So that's creating an extra layer of security really, because they're not gonna be able to know that there's another router or another network that it's connecting to. So that gives you that's the layer of security that actually I really like about it. I should have mentioned that earlier, but I just realized it now until you asked that question, so thank you for that. So yeah, this situation is only if you're going to set up a domain name. And if you want, you could just give somebody access to your SCaLE account with using the IP address, and they could just use the IP address to access SCaLE, like Jellyfin or Nextcloud server. They could do it that way too. There's nothing wrong with that. And like I said, you saw it for yourself. I used my SCaLE account, got access to it, but if you use that IP address yourself, you would not be able to get access to it. It's hidden. So as long as there's no one that has access to my credentials for SCaLE, unless there's breach or something, but usually as long as that doesn't happen, there's no one be able to find out that that one-on-one correct connection. They won't be able to see that. So yeah, this VPS setup is really only for if you're trying to set up a domain name and you want this to be accessed everywhere. So you could just say, here, go to this website or go to this domain name. You'll get access to my Jellyfin account, and here's your credentials to log in. You know, you don't have to have them set up an account, set up a VPN on their PC or, you know, Chromecast or something if they're trying to. They don't have to set up a VPN or get connected. They can just use the domain name. And again, like I said, it gives you that extra layer. So even, the domain name is open to everyone, they're only going to see the IP address of the VPS. So that's that one extra layer of security. So that way they can't see your personal private IP address to your router. And it's the same thing like Cloudflare Tunnel does. It's using the Cloudflare IP address, not your private IP address that's to your router. So that's the same thing. It's creating that extra layer of security. But the problem, like I said, is it's kind of limited, but you can still use it. If you want to use it for Nextcloud, you can use Cloudflare Tunnel. There's nothing wrong with that. You can use just SCaLE. If you just want to access using the SCaLE IP address, you can. Now, the problem with that is that there are some features that may not work, like if you're going to use Bitwarden. Bitwarden requires an HTTPS connection. So that means you would have to create some kind of certificate with Let's Encrypt to have that HTTPS connection. And it's a little bit simpler if you're using a domain name. It's a little bit difficult without it because you would have to create the certificate yourself if you're just using an IP address. So you can use the IP address itself from SCaLE, but most of the time it's going to work great, especially on Nextcloud. But I think certain situations that may require you to have a HTTPS connection. I think if you're trying to do, if you're like syncing your calendar or contacts, I think it requires a HTTPS connection. But if you're just accessing the Nextcloud app, it will work just fine with just the SCaLE connection. So nothing is better than, nothing is better. It's just there's different ways to do this. If you want it where you're only accessing it and nobody else, you can use the SCaLE IP address. If you want it open for everybody but have an extra layer of security, you can use the Cloudflare Tunnel, or you can create your own, and that way you don't have those restrictions that Cloudflare has. Now, I could add one more thing that I would say with Cloudflare Tunnel is if you're using something like Nextcloud or anything like that, Cloudflare Tunnel, there's a chance that they could have access to that information because you're using their encryption and they would have the keys for that. Now, I'm not saying that they're spying on you, but there's a chance that maybe someone out there could have access to it. So maybe creating your own tunnel might be a better option if you're really concerned about your sensitive data. Depends on what you have on your server. So that might be something you want to think about as well. But like I said, nothing here is better than others. It's just the way you want to connect it to your server. And you don't even have to use SCaLE. You can go the old way around with port forwarding. Just make sure you're using an HTTPS connection using a reverse proxy. So you're making sure that you're not opening too many ports. You just want to open the port 80 and port 443. Just as long as you use Let's Encrypt to make sure that there's an HTTPS connection, you'll have that one-on-one connection to your service, whichever you're using, with a domain name. So that's about. Any other questions? Sorry about that. Sorry if I went too long on that one, but any other thing? It's a very. There's so many ways you can do this, and it's very fun when you get to this part, because you can just do so many ways to find access to your server or anything. You can even do home assistants and set up a home assistant to get access to your cameras and just get access to it through your SCaLE account. Nobody else will see it but you. And no port forwarding will be necessary with SCaLE. Even if you wanted to do with creating your own tunnel and have an actual domain name, so you don't have to remember. A lot of times I do that. I'll do this so I don't have to remember an IP address. I just remember the domain name, but I know that I'm secure with having this extra layer. All right. Anything else? Any other questions? That's all I had. That's really all I had. So, if you really, if you have any questions or, if you want a copy of the slides, I'm going to post this up on the SCaLE website, but if you have any questions, you can email me or I'm on Twitter. You can send me a message. And other than that, everything else, that's it. Thank you.